Hello everyone, welcome to another stream. How's it going? So last stream we worked on some of this stuff. We'll go over this in just a minute. But we're gonna work on some more of this stuff today. Hopefully get this finished up and more. So we'll work on the texture viewer today. Hopefully we finish up the last set of features. So we can now select, like, this is the surface texture. We can select it at different points in time and view it basically, which is quite nice. Also zoom in and out. But yeah, we want to continue working on some of the features that we have left to do. There's this upside down one we want to fix, and this BGRA thing, and probably, what was the other one? Yeah, the zoom. It just gets slower as you get in far because I'm just adding rather than probably multiplying. So we need to fix those little bits. I think we should start off on those first. Let's jot some of these down because I really don't want to forget these. So it was a sort of zoom speed, BGRA, nuke BGRA, I don't know, and rename RGB to color or whatever. Color. Hey there, Egotist, welcome, how you doing? How's it going? Upside down images. How do we handle that? Because some of mine are upside down and some of them are not upside down, and it's just annoying. It's just so silly. And then we've also got the ones that we didn't finish last time. So let's select. No, we've already done that. We did these two. So yeah, we need the array layer, array layers, make array layers, an input box like we had before, but we changed it to a drop down because that's going to be used for 3D textures as well. Array layer being the Z component. We want the black white values. Black white so we can control the range that we view. We then want to be able to view individual color channels. Like that. How am I doing? Yeah, not too bad. I actually think I caught up on some sleep, which I thought was not going to happen. So I feel a lot more energized. And on top of that, I have myself a Pepsi Max Mango. I need to be sponsored by these guys, but I'm not sponsored, so... But anyway, Pepsi Max Mango. This thing is good. It's like as good as cherry. Can we get like infinite Henry pouring? Got some ice over this time because it wasn't in the fridge long enough. But yeah, it's gonna be good. This is the fuel for today. Oh, it's that mango aftertaste is so good. Cherry, yeah, I always go with cherry as well. I discovered this last week, and my wife just, it's funny, my wife is just like, she thought it was absolutely despicable that there is such thing as a mango flavored Pepsi. She likes the cherry one, but she really likes mangoes, like proper mangoes. And yeah, well, put it this way, she did drink 2 cans of it, and yeah, it was kind of funny. But I quite like it. It's good. Sweet, sweet mango. Oh yeah, and then also we want to get tabs done today. Right. Tabbed UI. these are the things I really want to do today. I think it's possible. It's a Sunday, we've got some slightly more time. And then if we do all these things, next stream we'll literally just be doing screenshots and sort of like getting those in the texture viewer and sort of all the stuff around that and saving those out to disk. So yeah, I'm hoping to be wrapping up on this texture viewer stuff next week. Yeah, so it'll be good. Be good. So I guess let's record some form of intro. Bum bum ba bum bum ba bum ba bum bum. Right, hello everyone, welcome to another devlog. So last stream we didn't quite get all those features we wanted to, so I've added them in here, plus added some more. So hopefully we want to get zoom speed done. Wait, well, hopefully. All right, so one more time. One more time. Hello everyone, welcome to another devlog. So last stream we didn't quite get all of these done, and I've also added some more. So today we want to get zoom speed, make sure that's sort of a nice feel, because right now if you zoom in too far, it feels like you're not. You know what? I should show this one off. I should have it at the ready. I should have it right here. Just not move the camera, that'll be good. Right, hello everyone, welcome to another devlog. So last time we didn't quite get all those features done that we had listed, so I've put them in here and I've added a few more, like zoom speed. We'll want to sort these upside down images, sort these array layers, black and white, viewing range, and viewing only the RGB array channels, and possibly getting a tabbed UI done. So let's take a look at this zoom speed and see why that is a problem. So here is the surface here that we're viewing it after we've done the tiled ray tracing. The image is upside down. That's not the problem. So when we zoom in, it zooms in proper quick. But as you get further in, with the rate in which it zooms in is, yeah, it just doesn't feel like the same. And that's because we're simply adding. We're sort of adding zoom. We're adding to a zoom scale, so I think we need to be multiplying to that scale. So we'll just jump into the code now and see that. Oh yeah. Boom. So we're jumping into the code to see that. View scale is a called, of course. So the MIP one already does this, right? You've changed the MIP level, well, you'll notice. Yeah, if you change the MIP level, it changes the zoom. This is why it's a problem. Oh, too far. Yeah, it changes the zoom. So if I zoom out now, it's actually going to be quite slow, and zoom in, it's actually quite slow. Because it's zoomed in, it's actually a smaller image. And now if I zoom here, it's fast. Whoa. Spooky. So, back to the code. Back to the code. So, this is the one. So let me just practice before we hit the record button. So I think if we just multiply. Instead of add. Let's give it a go. I'm gonna try it first before I hit the record and be like, yeah, so we do surface. Right, is that an integer? No, it's float. Oh no, we want to add, sorry, add 2 times. No, it's scale. Multiply 1 plus. Yeah, because this can end up being a -1 or +1 on X11, I think. It's not really that great. And then, yeah, so maybe we don't need that divide, sorry, yeah, this divide by 4 here, you know. So we just do a bit of a zoom now. Sweet. It stays consistent. This is what we want. But it's a bit fast. So I probably want to drop that. Right, so now we can record that. Oh, that's really fast. Oh no, I should have timed it by. Let's close that now. Okay, so right, let's get back to, let's hit the record button. Alright, so this is the code where we do the zoom in. So if we're hovered over the sort of place where the texture is rendered, if we've got some relative mouse wheel movement, we then increase the view scale by adding. This comes up as 1 or -1 on X11, and then it multiplies. Well, sometimes it's 2, I guess, but anyway, then it multiplies it by 0.25. So it's just adding that, and that's why we're getting that issue. So we multiply it, and we can't be multiplying it by basically 0.25, right? We've got to be saying 1 plus that, so it's 1.25 or 0.75 when this is a negative value, right? So I think that should be sensible. Let's give it a go quick. So zoom out, zoom in, and it's all the same speed now, which is great. So that's super nice. Happy about that one. But I don't know, maybe it's a bit too fast, so I think it's just tween it a bit. So here I'm just gonna maybe say 125, right? So just half that. So it should just be a bit smaller. Oh. Right, so now we zoom in. It's a bit more, it takes a bit more effort to zoom in. Maybe that was, I don't know. Torn between it. What's half this number? It's 60.25, isn't it? Yeah. Right, so let's go over values in between. So we add 60 to there. 25, so it'll be 7. There we go. This should be the speed that I want. Hey Glorious, how's it going? Right, that feels much better. There we go. So there's the zoom speed sorted out, and it's all feels nice now. Isn't that interesting, zoom speed? It has to be exponential for it to feel linear. Like when you zoom in, for it to feel smooth as if, yeah, interesting. Has to be exponential. Hey Dora, how's it going? Glorious, have you tried the Pepsi Mango? Got it in a nice cool glass of ice here. Gotta give it a go. Ah, so good. Yeah, so we can take that off to the to-do list. Ding. This is a crime. That's what my wife said. That is a crime. But then she had 2 cans afterwards, and her excuse was there was no other drink. That was her excuse. But yeah, she didn't actually buy it for me when I asked her to get it for me at the store yesterday, so I went out and got it today myself. Sad times. Right, so we're gonna nuke BGRA and rename RGB to A to color. Right, so we will explain that problem as well in the devlog. It shouldn't be too hard. Right. So I think I want to boot up the thing. Right, so as you can see, we've got some red spheres here. When we see in the texture viewer, it's upside down and it's blue. This is because it's a BGRA texture, because the surface needs to be in BGRA on the desktop operating systems. Because I was manually packing it into 32-bit integer, I explicitly had a BGRA mode, but now it's kind of automatically done by the driver, so we just need to have this RGBA mode, and so we should just call this color. And yeah, so we take a look in the code. Yeah, we should just get rid of the BGRA one. So obviously whenever you do sample something, and your format is defined as BGRA, it's obviously going to put the red channel in X, right? Y channel, which is going to be G, and so on. So it retains that order. So we just need to get rid of this one. Maybe we can offer some alternative swizzling in the future if we need it, but I don't think we will need it. So I'm just going to remove that all now. I'm doing fine, hope to soon. Why is BGI the default? Legacy reasons. It's funny how like the RGB part is back to front, but the A stays at the end. It's just, yeah. So it's not like it's a little big endian thing. It's just legacy reasons. Which I don't know exactly what. I've never seen Pepsi Mango actually, maybe someday. You should go to Asda if you want Asda. Sell it there. Right, so let's rename this color or couleur. Couleur. Seems sensible enough. Couleur. RGBA. Couleur. Right. This is something we want to tackle in the future, that is for sure. I want this is probably going to be a separate one. Oh no, just be a red channel. Maybe. Oh yeah, integers. We need to solve, that's another one with the to-do list. In 32, view in 32s and 3D texture. I think that will, yeah. Oh. Okay, so I think that all compiles. And I thought, right, oh yeah. So, yeah, now we're not getting, yeah, now it's red. Amazing. Okay, so we can tick that one off the list. Right, so I guess I need to just quickly go and say and show that actually. Right, so now when we view this, wait. There we go, okay. Right, so now when we view this in the texture viewer, it is now red. So we're just going to tackle the upside down issue now. Making sure my blind stays down. Okay, so what is next? Upside down textures. So why are they a problem? So basically the reason why they're an issue is because I refer to everything in bottom left coordinate space, but Vulkan wants you to refer to everything in top left space because they decided to change their mind when it came to Vulkan. And OpenGL was like bottom left and sensible. But yeah, so we went and took a step back in that side of things. So this means when I write to images, I will write to them I won't bother doing the conversion, but when I write to the final swap chain image, I will manually do the conversion, where I will flip it upside down. So the swap chain image is always going to be upside down, whereas everything else probably won't be. So when we view like the logo, it's not upside down. When we view the font, it's not upside down. Right, the horrible font. When we view the occlusion texture, it's not upside down either because we never flip it. But the surface texture is upside down. So I guess I can just make a special thing for that. Oh, there's a pixel lit up. Ooh. Oh, occlusion. Oh, occupation map. Yeah, this should have more layers. Oh, weird. This is the 3D texture we need to look into. 17 by 17 by 17. Okay, so maybe we shall do that. I guess it can be a special case for the surface. Yeah, right, let's explain all that again. A bit more condensed. Bum 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 bum. With Milton involved, so people can see me draw a box or something. Okay, so where the upside down problem is happening is in OpenGL. Okay, we've got a green box today. In OpenGL, the addressing inside a texture was from the bottom left origin, right? And now in Vulkan, it's the top left origin. So 0, 0 is up here, right? I quite like the bottom left because it's like a graph, you know, across the X and up the Y. But we're here nowadays for some reason, especially, you know, in 3D. Bottom left does make sense. So basically, when I render the final like swap chain image, I flip the texture upside down in the shader right at the end. So we can go and see that code in just a second. And so basically what we need to do is inside the texture viewer, we just need to say if with a surface texture, flip it upside down. And that should be fine because that's the only texture that's going to need it. So let's just see those two things now. So I'm glad I drew that box. It's in the graphics side of things. So GPU is the GPU abstraction. Graphics is where we use it to do graphic stuff. So if I go to the tiled ray tracer right at the end. Yes. Okay, so this is at the end of the tiled ray tracer where we have ourselves something like the closest depth and we have ourselves a final color. Notice here how we have this thing called coord, basically unsigned coordinate. We just throw that right into the text, the depth texture, and just put the closest hit depth in there. But here we actually flip the coordinate upside down, so we take the screen dimensions, take away the coordinate .y and take away 1, and then we assign it back into the y field here. Then we say if it has a non-transparent. I need to say that again. I messed up. It's so close. Damn it. It's alright. Okay, so this is at the end of the tiled ray tracing code, and you'll notice that here we are putting out the closest hit depth into the depth texture at this coordinate here, and this is the pixel that we're rendering. But we don't end up flipping it. The flipping code happens underneath. So we essentially, use the screen dimensions, and then from there take away our current coordinate on the y-axis, and then take away 1 and put that back into the y-coordinate. So if we have a final color that's actually not fully transparent, we then convert it into sRGB from linear, and then we do the BGRA swizzle here, and then we chuck it out into the output texture, but it's flipped now, right? So yeah, this is just the example of where we end up doing the flipping code. It's only when we render into this surface texture, but not any other texture. Cool. I'm glad that was said. So what is next? Now we're just going to put an if statement in, right? So I guess we need to put it inside. Is there a dims? There must be a dims that's passed in. Yeah, easy. So I need a little boolean. I guess we can do flags. Yeah, we'll have flags. So I think what we'll do is we're going to add, we're going to need flags because we've got that int problem we want to solve as well. So we're going to do another one of these, I reckon. Texture view flags. Flags. So the first flag is going to be flip. We obviously need a none. Sweet. Looking good. So, then obviously CPU side, when you fill that in. So, wait, what was that called? Yes, this is when we do dispatch the texture view a copy at a certain point in time. We copy the texture out into another texture and do the translation there. So we need to get all the flags ready. So I guess you could just put it right in there. So flags equal GPU texture view flags none, and then if that the current resource tab resource ID.raw is equal to GPU.surface resource ID.raw, then that means we need to OR the flag on to say flip it. And then that's given to the GPU, or it's given to the shader invocation. And then here we go, okay. If BC flags and GPU texture flags flip, we simply perform SV. Now, unfortunately, we need to pull this out into its own thing. So it'd be coordinate SV dispatch index.xy. So I guess it's a lovely 2D coordinate. So where there's an SV dispatch, let's replace that for coord. Shoot. It's storing it upside down. Sorry, it's storing it in the same coordinate. So the flipping needs to happen in... Wait a minute. Do you do it in the same? Yeah, I need to put the flipping after I do the sampling or something. So I need to say coord.y equal bcdims.y take coord.y take 1. So I think that oh shoot, there's another one called coord. No. Oh, here we go. So let's give that a launch. Hopefully this doesn't fry the computer. Right, we're still here. And it seems like it's not upside down anymore. Look at that. Oh yeah. So are the rest not upside down? Depth texture, it's not upside down either. Cool, so let's go over that and recap and explain it. Recap time. Okay, so what we've done is we've made this sort of texture view flag so it gets passed into the shader that does the copying of the texture viewing texture at the point in time when we want to view. And we're just going to put this, it's just called flip. So anytime we want to add more flipping capability, we just make sure the CPU adds this flip parameter into there, or flip flag. And we can always add more flags in the future. That's just passed into the push constants here. And then CPU side right now, we're just saying if the currently selected tab resource is the surface resource ID, we just say, hey, flip it in the shader for us, please. Send in the shader code over here. After we do the sample of the pixel, right, if the flip flag is set, we flip the coordinate, we do some reinterpreting of the pixel to display it as a different color or something like this. More to come in the future. Then this coordinate here is now flipped, so it'll just be displayed upside down, or actually the right way up. Right, so if you notice here, here's the thing that we're rendering, and then we open up the text viewer and view the surface. And as you can see, it's the right way up now. There we go. So let's move on to the next one. Awesome. So upside down images, check. Right. Which one seems more interesting? So these ones all go really hand in hand, I think. They're a bit of like a, yeah, they should be done kind of together. So then, because we've only got one thing with array layers, like a 3D texture basically, and it's a uint. Yeah. I guess let's just do that. Let's just get out of the way, right? It's a little bit more involved, but challenge accepted. I guess we should describe what we're doing. Let's open that one up. Okay, so the next one on the list is this make array layers an input box. We changed it from a input box into a combo box, but actually it's the wrong idea because we can have thousands of entries here. So yeah, back to an input box it is. And we have a 3D texture that we want to view, and that's controlled by the array layer input box. And it is a uint 32 instead of a floating point number that we're viewing. So if we go over here and look into it's the volume constructor cluster occupation map. So it's a 3D texture, 17 by 17 by 17. And there's actually one pixel that's lit up here. So every bit in this 32-bit integer that's stored at a pixel represents a cluster if it's occupied. So we use this to quickly check if all of the clusters around one cluster, if it has a full set of clusters around another cluster. And if that is true, then it means we can get rid of it and use a lower resolution version. So let's just draw it up quickly. Basically, you got a cluster, you have other clusters that go around like this, and each bit represents a cluster that's fully occupied, that's filled with spheres. 4x4x4 set of spheres each cluster is. But we're going to use one bit for each cluster, and a 32-bit integer here. It stores kind of like a 2x2x2 set of clusters, and we basically repeat the information in the remaining. Let's do one more column. It repeats the information of these. These come from the next word that is below us. These come from the next word that is diagonal to us. These come from the next word which is diagonal, which is to the right of us. So this means that we can basically, whenever we want to check if a single cluster is completely surrounded, we just make sure that it lands in the middle here. If it's one of these clusters here, we can then just sort of like check one 32-bit integer or two 32-bit integers, because it's actually 3D, so the one behind it, and it's very quick. We don't have to sample a bunch of different 32-bit integers. We could just sample two and then take a look at them. So you're going to try and view this information in this texture viewer as well in some way. Okay, I'm glad we went over that. Hopefully that made sense. So the first one is making this. All right, here's the combo box. So we had this before. It was an input U32, rectangle value style, and then afterwards we had a clamp. So clamp, so tab array layer equals clamp, tab array layer 0 resource texture array layers. So take one because it's an index. So I think, right, we look at that now. It's disabled. Why is it disabled? Right, or it's got to be 3D. GPU texture type 3D. Oh yeah. So, then if it's 3D, you want to use the resource texture dim z. Yeah, because we probably were better off just be reusing the same integer there. It would make a lot of sense. Maybe the array layer should just go in the z component of the dims. Always. But well. So we try that out. Whoops. So it's disabled if equal to 1 and not 3D. Is that right? Yeah, I think so. Wait, what do? Sweet. So it's enabled here. The logo is not enabled. Yeah, I don't know if I have anything else which will have it enabled, so that's fine. So we put in here like 19. It caps at 17. That should be like 1 pixel big. But yes, 2, 3. So we're seeing it move now. We should start seeing like 5, 6, 7, 8, 9. Right, so we're seeing it move. You should see. I don't know why they're. So these ones must be completely occupied with neighbors. I don't know what's going on though. But yeah, let's document that. Okay, so we've gone and changed the UI code now. So now in here we've got this disable scope where this section is only disabled if array layers is 1 and it's not equal to 3D texture. If it's a 3D texture or has array layers, then this is enabled in here. So this used to be a combo box, it's now an input box, and we make sure that we clamp the array layer to be the array layers take 1 or dims. It should be dims take 1 as well. There we go. So dims.z will be for the 3D texture. So we run that. Let's go and take a look at the viewer. Right, so we're viewing the occupation map here, and here's the layer thing. So we put in like 18, you'll see that it clamps it to 16, which is the number of Z components here. So it's an index, right? So just take 1. So you'll notice here as I type it, it is changing the image on the right hand side. I'm just incrementing the value. So we are seeing the value, but it's being represented as a floating point number. As you can tell here, it's a 32-bit uint. And we're sampling that, or we're fetching it as a 32-bit integer and then just interpreting that. So we need to add something to do with like, hey, this is an integer, how do you want to view this thing? So let's work on that now. Cool. That's pretty good. So we're going to tick those things off. Tick and ooh. I guess 3D textures is ticked, but that's already kind of there. Just delete it. Right, what is so how are we gonna tackle this 32-bit integer problem? Let's think about it. So we obviously need to add a flag. Say, hey, the type of this thing is an int. So handle it in a different way. So in the shader, so obviously we'll fetch it out, and because it's only a fetch operation, it's not like it'll give us the exact value that's in the texture, right? It's not gonna bilinear sample it in any way or anything else. So this code is all fine. It's just a floating point value, though. It thinks it's a floating point value. So this is where I guess, so the viewing modes, right? Y of non-zero, 1 of non-zero, these can work with integers. Color, That one cannot work with an integer because it's just, it thinks it's a floating point. Well, okay, so it might have picked up. No, if it's a uint, and then it picks up as a floating point, there'd be a bit of conversion in there. So, and then depth as well. Hey there, Chandu, how's it going? Master Vulkan. I guess I'm quite good at the API. Thank you. Appreciate the compliments, sir. How are you doing? Just need to get better at doing stuff on top of the API. You know, the graphics part. So maybe these are only viewable for floating point ones, right? If you have integers, maybe, well, I don't know. So effectively, you can have an integer range. It's like 4 billion, 0 to 4 billion, and you're going to want to represent that as a color. So you probably want to do a similar thing like you're doing here with the depth, right? But obviously the float isn't really good at representing 4 billion or values near that, is it? Because it's a 32-bit float. So if we were to say reinterpret cast the pixel into a integer and then do some kind of division, then you're not going to be able to get into a floating point very easily because that thing is a is an integer, right? And you're already yeah. We basically want to turn it into a color of some kind. So I guess there's going to be a viewing range, like this black and white viewing range thing. Like we'll use for this. We'll use it for that integer color as well. But it's a bit set that we're trying to view specifically. I wonder if there's a way that we could view this. Yeah, so we probably want two viewing modes. One which is like for viewing an integer. That you can do some sort of range thing yourself and move it around. Then so we'll somehow get that to work. And then viewing this bit set is like, well, we only need to probably view a 2 by 2 by 2 set of bits. But then representing that as color would just be weird because you can have all these different bits on and stuff. So, well, 2 by 2 by 2 by, wait, 2 cubed, right, is 8. So you could end up just setting some of the bits. Nah, because then you got RGB and then you just have different shades of R. Yeah, maybe not. Yeah, so maybe just having that integer view mode is good enough. What happened to the $1 trillion idea we spoke about? I forgot, remind me. What was this $1 trillion idea? So good. Alright, so let's pencil this out. So we are viewing an integer. Maybe just say view mode int. Maybe you can only view an. So you're viewing an integer. You're going to reinterpret cast the pixel as, so bits bits from F32 times 4. So you'll get pixel and you'll get your times 4 ints. So there's your 4 integers. Now, what you want to do, so let's just sketch this out a bit. So in the red channel is where this is going to be. It's just a single integer texture. So it's just going to be in the red channel. So the maximum value is like 429. I don't know the rest, but it's 4 billion, right? U32 max. So if we did that, you're not going to get a value from 0 to 1. Furthermore, if you cast it into a float, I don't really know what this does, but I imagine there's precision issues when you are just a little bit away, but maybe it's okay just for the texture viewer. But yeah, you can't represent a 4 billion value in a float, right? So I think there's going to be some real big issues there. But then I'm thinking that maybe if you're in integer space, why don't you have it? The problem is this is in linear, or is it in linear? This is a good point. I've gone and grabbed this. It'll be an sRGB. You don't know if it's sRGB or linear. Oh, this is something that we need to do. So usually that's automatically handleable. We don't have that because we use compute shaders. And you can't write to these. Hey Kazans, how's it going? Kazanza? How's it going? Thank you so much for the raid. How you been? Okay, so I think we need to actually add sRGB textures because you can use them when you sample, and it's going to make sense for this. Yeah. So sRGB. I just thought about that. We need to add sRGB. So when you sample something, it needs to have the automatic sRGB conversion into linear space, but not when you store out via you use a storage texture. Yeah, we need to add those. Because in the texture viewer, it just look weird, and I can't do a manual conversion between sRGB. Well, I have to manually mark every texture anyway, and that's the way of marking it. But anyway, that's a different problem. So yeah, what I was thinking, right, is along the lines of that sRGB thing, right? So because it's a UN, why don't we make this? Why don't we somehow divide this in such a way where it falls into an sRGB color value and then turn that into a floating point, right? So basically, we figure this one out. I think it's possible. All right, there's our number. Refactor my code to use interrupts. Ooh, just finished some Arduino. Nice. Yeah, I get you, man. Yeah, when you finish stream, you just want to collapse. That's cool. Have a good one. Thank you for the racer, and yeah, see you around soon. So right, I reckon. So the problem is I can't multiply anymore because we'll overflow the 32-bit integer. And we've got 64-bit ints in the shader. So what I'm trying to think is, can we in some way somehow get to that 256 number? So it goes from 0 to 256. So if I divide this by 2, I think it might be a bit weird. Oh. Huh? Why am I getting point whatever? I guess I do. Oh shoot. Yeah, so 255. There you go. Wait a minute. So if I add 1, which is going to be out of bounds, divide by 256. So we could always just shift right by 8 and get that. Yes. Can this help us get a number between 0? So if you have like a maximum U32 value basically, and you want to get to 256, can this value be helpful? Hey there, Wajilla, how's it going? So we've pre-divided this thing by 256. Or maybe you pre-divide both values by 256, turn them into floating point. I guess you've lost the precision then. Yeah, I wonder. Oh, So if we then say, right, okay. No, because anything less than this value would just be below 0, and anything bigger than this value would then just be above 1. That ain't gonna work. Yeah, this can't help us if we did this. Hmm. Yeah, so maybe you say, or good. Point my renderer to not use pipelines and completely dynamic for easy use. Cool, nice. Yes, using that dynamic or whatever it's called. Dynamic state? Is that right? VK dynamic state, I think. Yeah. Oh, there's an extended dynamic state now. Oh my days, what have they done? What have they done? Oh no, it's the same one. Probably. Oh, this one. Oh no, this one isn't too bad. I thought you meant the other one. Yeah, this is good. I think some of the stuff, it doesn't matter. Like having the... Wait, have you completely got rid of pipelines? And I don't think you're using this, right? You're using the other extension? There's another extension that allows you to get rid of pipelines. But yeah, having a little bit of this changeable state isn't a bad idea. Right, so how could there be a way that we could turn this integer into 0 to 1 floating point without losing any hmm. How can we do that? Let's try out of this. Um to 0 to 1. But I reckon most people are gonna say convert to 64-bit int, but I can't do that. Yeah. Use a double. No. I ain't gonna do it. What is this magic? I just need to set up pipelines on the fly. Technically, this lets you get rid of pipelines. Well, not all of them. But yeah, some of the dynamic state. No, that's not the one that allows you to get rid of pipelines. You still got to use the pipelines to use that one. There's a not extended dynamic state. There's another one. Shader objects. This one. Yeah, you can use it without pipelines today with our extension, which implements pipeline caching behind the scenes. Crazy. Yeah, you can use this one, shader object. I don't know how much hardware supports it, but it's growing. Shader object. So you basically create shaders now, and then then everything else is dynamic state. Everything else. And this allows you to get rid of the pipelines. It has some pros if the hardware is all in on it, but pipelines are pretty good abstraction. It just doesn't work for Unreal Engine or things that use like shader permutations and have high numbers of permutations. It's I don't know. It's all right, but I don't think it. You know, pipeline creation for most people is not a big issue, and it's like a very short amount of lines of code. The biggest thing is probably synchronization when learning Vulkan. This is an easy problem to solve without this extension. But yeah. Um, precise convert integer into float 0 to 1. Once it's asked like this, half the floating point numbers are in an interval are in the interval -1 or 1. Could you suggest how to make use of this fact and to replace a naive conversion? Wow. It's good for 64 but slow on CUDA, exactly. It's impossible if you don't have 64 bits. In the case you drop the uniform distribution constraint, it's doable 32 mass alone. I just need this one. A union though? Oh right, but I have a reinterpret cast. It doesn't matter. Yeah, precise. So I'm trying to convert a uint into a floating point from 0 to 1. And I'm concerned about the ones at the high bits. Is that a problem? Is it alright just to convert it into a floating point number? So the ones that are near the end, like this number's not representable in a float 32, is it? Is it just the last digit? I don't know, because like basically the way floating point works, right, is all the precision. So how would you graph it out? So if this is 0, this is inf, if you will. I don't even know, it's probably a bad way of saying it. The max value for a float, whatever that is. All the precision, and up here is the precision. All the precision is up here, and it's sort of, yeah, I don't know how to graph it out, but basically it drops off rapidly after 0 point, after 1 basically. I don't know how to graph it. Maybe it's something like that. I think it's something like that. So the precision is actually really high at the small values, and as you get up here, it's basically non-existent. Yeah, I think it's something. Wait, 2 to the power n. Yeah, so if I'm using an integer and converting that to a float, there'll be so much spacing between these ints up here. Like 4 billion, I don't think is representable. Yeah, it's got like a mantissa and an exponent bits, and it's got some special other quirks as well about it. But yeah, maybe we can do something like this. So if you drop the uniform distribution constraint, I don't know what that means. Oh, uniform distribution. Okay. Tertiary is only 29 bits plus sign, 30 bits of an integer. To avoid denormalizing numbers. Havoc, what I'm too lazy to encode. Much slower, more complicated. Okay. But the distribution not linear nor uniform. Red is the floating point range, -1 or 1. So it's got a bunch of 0 here. Blue is the integer. Yeah, that's not uniform at all. Look at that. Wait. Yeah. That ain't good. Reason use floating point is to get accurate for a specific number. What? Yeah, I know. But I need to make it into a color. I'm trying to, for the texture viewer, I need to view it as a color. So I need to say how much of this integer is on, if you will. How close is it to the max value? And that'll be progressively more and more red. Um, um, Maybe there's a decent way. What the crap is this? Because the multiplication to get from wait, is this the other way around? Float to, okay, this is the wrong way around. Right, thank you. Those who achieved, appreciate it. Has achieved a precise conversion of a 32-bit signed into a float -101 super plus. Oh, this is what we want. Are they going to use doubles? They didn't. You can achieve a precise conversion by bitwise operations and scaling. Here's an example. 2. Mask the most significant bit to get the range from 0 to 1. That's what we want. Not -1 or 1, but that was easily convertible. Normalized value. Divided by that. Okay, so we get rid of the high bit. Then convert. What? It's getting rid of the high bit though. See, that's 31 bits. I want 32 bits. But yeah, you can obviously do 31 bits. That's not the problem. Right, what's another way? Perhaps we could do it. So yeah, the other alternative was we get between 0 and 256 somehow. We've got to turn a value. We've got to get the integer within a range of 0 to 256. So if we divide both the values by 256, maybe like shifting, you'll get rid of the low bits. I guess you can always add them on later. Maybe that's the way. Maybe what you can do is like yeah, maybe you can take, or maybe you can do the upper 16 bits, lower 16 bits, and you could probably get some form of value you could then combine. Let's have a think about that. So perhaps maybe you take okay, so this will get you 0 to 1. For the low bits, and then 0 to 1 for the higher bits. Is that a helpful way of? Oh, sorry, you need 16 bits. What am I doing? Okay, so low 16 bits and high 16 bits, you get 0 to 1. separately. The problem is though, the upper 16 bits are like way bigger. So is that so perhaps you so see all these 16 bits on here. You got a 0 to 1 range, which represents this here. 0 to this value here. And then you got 0 to 1 range for this one here. See, I don't know if you could combine them though. Because that would be because you'd be 65, you'd be 64k away from the biggest value if you had all these bits on and all these bits off. Right, you'd be 64k away from that max value. Yeah, actually, maybe it might work. There might be, so this 0 to 1 range here with the upper bits, these ones here are the upper bits. No, I didn't do that one first. So these are the upper bits, perhaps. So 0 to 1, basically from 64k and above. I reckon something to do with like, so you can say that's 0.5. So maybe if you scaled it, by 0.5 plus 0.5. So it's minus, so it's 0 to 1. You're going to half it, then add 0.5, so it'd be from 0.5 to 1. So from 0.5 to 1, is that enough though? Because I think we're missing, the way it's going to be stepping over is going to be a bit off. Because it's, why can't you just do the F32 and do the division? I think it would fit into F32 nicely. Yeah, I'm not sure, will it? Like, I'm just thinking about how it works, right? Floating point, you have a lot of precision in the low bits, and it falls off. I wonder. Where's the sort of way you can play with a float? Um, yeah, there's an interactive website where you can play with it. U32 max would be in the exponent, the mantis would be 0. Oh, this one here. Yeah, I guess this one's better. I've seen an even better one, but it never shows up in Google results. Thank you, Clarissa. So what you're saying is if you chuck a U32 max in there, right, so it's all the way up there. Value actually stored in float. Okay. But how do we, so we take away 1. Error due to conversion, right? How much error is there? Like, right, 6. Yeah, maybe, I don't know. So how, if I reduce this to 8, 16 error, right? If I drop 100 off that, that's a lot of error, right? So apparently there's 100 and whatever error there. Okay, so what's the range? Maybe it's not so bad, actually. You might be right there. Okay, so it only gets 128 off. Yeah, actually, maybe that won't be so bad. It just skips 128 values. Maybe that's fine. Yeah, I think that'd be alright then, actually. Thank you, Clarissa. I appreciate it. Yeah, so that would then mean we just have to convert them all into like properly convert them all into yeah, we should also convert the alpha one because I think we want to view the individual alpha channel afterwards. Okay, so the thing would be cast a float divide by float U32 max. Alright, that's probably fine then. Okay, so if we have a view mode in, getting back to where we actually was, okay, that's a detour. View mode in. Yeah, I guess. So maybe it won't be a flag then. So there's a bits from on the pixel. Then outputs a color. And I guess we can always add more integer-based ones later on. So I think then, so just remove that one. Don't have that flag anymore. So this means when we select the viewing mode, your default one is going to be view mode in. So I guess it could be uint and assigned in. No, it's a uint. Let's call it int for now. Um, so we just gotta make sure. Yeah, I think it should be alright then. It should just select it. Let's just give it a go. Right, so here's our volume constructor. We're now seeing actually it's different now. If we go through the slices now, there's our ball. Look at that. So it's been occupied. Okay, that's good. So sweet. Right, that's good. So then we can actually tick that one off, and then we'll do a recording of that one. Ding. Okay, so what we've gone and done is added a new view mode for integers specifically. It takes the pixel and does a reinterpret cast and turns it into from a floating point, from 4 floating point values into 4 uint values. Right, since we just did a sample and it fetched out a pixel. Sorry, all right, one more time. Okay, so to solve the problem with the integer textures, we still sample out well, actually we fetch, right? Just do a fetch, so there's no sampling and any sort of bilinear filter or anything. It's simply just fetching a pixel out, and it reads it back as a floating point number, or at least it thinks it's floating point. So we now have a viewing mode for an integer, and all it does is it does the reinterpret cast, and then you get back a integer with 4 integers instead of 4 floats. And then from here, we are essentially just doing the division, converting those into floating point, and doing the division from the maximum integer value as a floating point. And so now when we take a look at the occupation map, so this is only used in construction of the volumes. Notice here how our volumes are all just a bunch of spheres. So each bit represents a sphere which has, each bit represents a cluster which is completely filled with a 4x4x4 set of spheres. So this is against the edge, layer 0. As we increase through the layers, you see more and more of a sphere appear, and as we keep going even further, it will start disappearing. So I think we're right in the middle, somewhere around now, maybe not. 10, 11, 12. So now it disappears, going towards the edge of the texture. So now, as you can tell, that we are actually viewing this integer thing a lot better. So that's really nice. Cool. So we can move on to the next one. Units now. sRGB conversion. We need to stick that one in. I think I'll just do that one regardless. Oh, no, maybe we'll comment about it. So where is this in? It's in the formats, isn't it? So we're going to the GPU header unom. Okay, so there's one kind of issue with the texture viewing right now, and that is we don't distinguish the difference between a non-sRGB and an sRGB texture. So if we were to sample or fetch from the shader here, it's not going to do the automatic sRGB conversion for us into linear. So when we operate on the stuff, it will be in, some will be in sRGB space, some will be in linear space, and we could do it by adding more flags and doing it manually, but also we could just have it automatically handled for us. The reason why I haven't done them right now is because typically we just use compute shaders, and you can't use the sRGB formats on storage textures. but it's fine on sample textures. So for sample textures, we'll just add an sRGB mode for each of these BGRA and RGB ones. So add those now, and that should sort out any issues with the colors that we should be seeing. Right, so it's going to put these in places. So you will have it in. Oh, do I have linear? So the texture viewer. Ah, shit, what is the texture viewer doing? Sorry, I meant the UI. What is the UI render? How does that work? So UI render, when we view some texture or something like this, we end up sampling. Yeah, and then overall the color that gets accumulated ends up being turned into sRGB from linear. Right. So what does this texture viewer copy need to be? So right now it's not doing the automatic sRGB conversion. Wait, sorry, did I? Ah, it does the conversion here to linear. So why don't we leverage the hardware version if we can? Since yeah. So I think maybe we can get rid of that. So if we get rid of that line, you'll notice that the rendering is actually quite bad when you view stuff like, wait. This, look at it, it's horrible. This is meant to be kind of like dark gray. So we've messed it up now. So we're going to fix it by using the sRGB format and getting it to automatically do the conversion when we sample. Now you can use sRGB when you use render passes and they are the render targets or attachments as they're called in Vulkan. And it'll do the conversion for you there when you write it out in the pixel shader. But we don't use pixel shaders, we use compute shaders. So you can't use it in storage textures for some reason. They don't like putting the conversion code in there. So yeah, you have to do it for yourself if you're doing compute shaders, which is fine. That's the way we've been doing it. But yeah, we've got an issue now where it'd be good if when we sampled it, did it automatically, because if not, it's got to be done manually based on a condition somewhere. And yeah, probably not a good idea. So the short names, sRGB, sRGB. Then after we've done these, we've just got to do it in the Vulkan backend, which is super easy as well. Did somebody... I don't know what I did here. Oh, I think it did the autocomplete and it must have messed it up. Something like that. So in the Vulkan backend, here we need to add two new lovely ones. So sRGB, sRGB, and the VK format sRGB. Oh, I did it again, didn't it? Don't get BGRA sRGB. No, what have we done? Yeah, you do. It's right here. Oh, right, okay, it was the, looking to show your object thing, this actually is exactly what I wanted. And the hardware issue isn't a problem for me since I acquire one GPUs anyway. Cool. Let me, tell you though, there is a layer. If you're reading that blog thing, they provide a layer. So if you ever need to roll back into using pipelines again because of some hardware, they provide a layer which automatically does this for you. Shader object. Here you go. So this basically does what, in a very super general way, it does what anyone would just do anyway in their code base. They'll make a they would cache it in a hash table and based on parameters. But this supports like all of the Vulkan things, like even ray tracing. So basically they cache all of the state and they'll compile into pipelines behind the scenes. So this is always a fallback option if you need to do it. It's in the extension layers thing. So it's got a way to be backwards compatible. But yeah, if you, for me, pipelines, I think they're quite fine. They're not that bad. They're just annoying for people who want to do permutations. Yeah, so we added the sRGB thing. So now, inside, or we create textures. Let's just find where we create those textures. Unorm ones specifically. So, well, actually, we did it in the GPU side as well, right? All right. Okay, so the texture viewer, when we display this one, it should be an sRGB. The surface is actually sRGB as well. When we sample it, we want to view it as sRGB, especially in the texture viewer. These are all sRGB as well. But you don't always want that, right? But if it's a color texture, you want it. So we run it now. Shoot. What have I done? Find out. Oh, I didn't just. Okay. So when we create the fake swap chains, fake swap chain image, yeah, we end up having to do an extra copy in our backend because the way we want to write to them from compute shaders and sample from them as well, which is okay. Hang on a minute. sRGB with tiling optimal only supports. Oh wait, you can't use it as a storage image. Yeah, I don't think you can use it as a storage image. If it contains storage image. Ah, right. So you can't. Right, this is fine. It's possible. I just got to untick that storage usage on the view. Is that right? On the view? Oh no, it might not be okay. Because there's not one on the view. Then the image format must contain format feature storage image. Okay, whoops. Where is this? Vulkan core. So where's this thing? Linear tiling features, optimal tiling, okay. So the format properties, so that's the properties of it was supported on the hardware. So maybe it's saying it's not supported on this hardware. If image contains, then the view format must contain. Yeah, it's not supported. Okay, so maybe we can't do it. Yeah, that's really annoying. Like, this is such an annoying thing in Vulkan. These things can change between hardware. And it's a very difficult thing to judge without owning the hardware. You can't even use the database tools like GPU info to find this stuff out. It's quite annoying. Okay, so maybe we don't add these things. So when you sample out from a shader, this could be an sRGB or a linear space, and you don't know, so you have to provide a flag to say, hey, do the conversion or not. That's super annoying. Unless we don't use the sRGB stuff under the hood. But we still keep it as an sRGB thing. No. So for the UI, it just makes sense to always actually perform this sRGB to linear conversion anyway. When you sample something, because you're displaying a color texture. And I guess very rarely will you actually display. You will never display in the UI system, at least, unless it's this texture viewer, non sRGB textures, right? And in the texture viewer anyway, the hope is you're outputting into this destination texture some sRGB value, so when it's presented to the UI, it's an sRGB. Okay, so then it probably falls to the texture viewer. How do we know that the texture of the viewing is in linear or sRGB? I guess you would just have a color mode and you have a linear mode. That's it then. Okay, so let's undo this change. It's fine. That's okay. So you'd have to manually select linear instead of color. But I think that's fine. Anything else we're missing? I think graphics. Yeah, these guys. Yeah, we changed those. Cool. So let's go ahead and add that linear mode then. linear mode. So this is going to say, well, or maybe it should be a checkbox. Like you should be able to check linear. But then again, depth is linear, right? Wait. Color needs to do the sRGB. Oh, it's in the damn graphics thing. I've not included it yet. We need to move this into the GPU stuff. Yeah. Right, let's move these around. They're defined in the wrong place. Where's GPU shared? Here we go. Blend pixels front to back. I guess we'll bring that into GPU as well. Should we? Probably not. So I'll rename these to GPU now. So anytime we use them inside here, GFX sRGB. What's the other one? HSV. Well, we'll see how it errors. Right, GFX linear. I think, is there a HSV one as well? Yeah, HSV. Okay, so that's all converted over now. So how do we want to refer to right, sRGB to linear, and then you want to convert it back into sRGB space here. Color. So if you want to view in a linear mode, like what is that? Like here it can be in linear, that's fine. So if you want to view, like I guess imagine if you have like a roughness or a metalness, you know, like PBR textures or whatever. You want those in like a linear space, right? And not in an sRGB space. So these ones, see that's where the texture format's handy, but you can't know, like we can't know from the CPU if they are linear or an sRGB because we don't have a specific format. So it could just be a button, or it could be another mode where you just say linear. I guess we'll do that. Cool, so let's just add those quickly. Yeah, default to color. Right. So we run that, and then we can talk about that, and then we should be able to move on to the next feature, which would be cool. So view the surface. It's looking alright, okay? We see the infinite version. Then if we view the linear version, it looks a bit brighter, right? As you would expect. Ah, nice. Sweet. So I guess we could talk about that one. That views, okay, it's all red. Cool. Cool. Okay. Oh, it got rid of all the Vulkan era stuff, didn't it? Okay, we'll record this one now. Okay, so the way I've gone to okay. Let's go the one again. Right, so we had the issue of when we sample these textures, they can give you back a linear or an sRGB value. You don't quite know. So initially I was going to just use a texture format for that, but then we gave it a go, and Vulkan was complaining that you can't have something as a storage texture and use an sRGB on it. So I've just decided to add a different mode for the viewing mode. So we have a standard one, which is just color, and we just assume all color ones are going to be sRGB and have to be converted into this more words today. I'm getting a bit hot. Okay. sRGB to linear space. Yeah, I kind of forgot what I recorded before, and I want to ditch that previous recording, the one where we added the textures, texture formats. But I think, yeah, I should be right. Okay, so we have an issue with the sRGB and linear textures. So when you sample or when you fetch a pixel here and it is a color texture, it could be an sRGB or linear. Well, okay, if it's not a color, it shouldn't really be. Okay, let's do it again. One more time. Right, so when we sample a pixel here, or fetch a pixel rather, if it's a color texture, it's an sRGB. But if it's kind of like a like color texture, like a maybe metalness or roughness, for instance, in PBR, that one is going to have to be in linear, is in a more linear space, and you don't want to do the conversion. So now our color it does the sRGB to linear conversion, and if we have the viewing mode of color linear, it just copies the pixel over and we do nothing about it. And then afterwards we will convert it from linear into sRGB space and then throw that out into the texture copy texture that we show on the screen in the UI. Right. So here's an example with the surface after we've ray traced the spheres into it. We can change color now to color linear and they'll go a bit brighter now. And you can also see here with the logo, if you change that to linear, it goes a bit brighter. So obviously when viewing stuff in a linear space, this will look a lot nicer. But yeah, this is sRGB, so this is the way it needs to be viewed. Cool. Yeah, so I don't actually have any linear data yet, but when we have it, it will be good. So to-do list, sRGB stuff, it's all sorted out. That's good. Black-white viewing range. This one's pretty cool. So this means we can control the depth. Right, let's hit record on that one. So depth texture. Okay, so the next one to tackle is this sort of depth range. There is kind of a bit of a bug with the depth right now, whereas the stuff in the middle doesn't get a depth value recorded, and that's because I got some transparent spheres and it just goes all the way through them. But ignoring that, what you see is there's a sort of as you get closer, it goes black, and as you get further away, it goes more to red. But what happens if you want to change, like, how close the near value and how far away the far value is? So that's basically, think of that as a black and white value. We want to probably use this for both color and depth textures. So we're going to add a couple of sliders here for black and white, and we'll be able to make it so this is all tunable without having to manually move, or so it'd be very great when the scene is very populated to just view certain aspects of it. So let's go and do that now. Okay, so black white value, we're gonna add a couple of sliders in. Let's find the view mode. Here it is, the view mode. So we want to add 2 sliders. The issue with black and white is when it comes for the integer viewing mode, you want to make sure the value that you see is the value that you end up seeing is big old integer value. Maybe that's just a case of so it could probably just stay as floating point, maybe. Yeah, I wonder how we don't really have a lot of room. So let's think about this. So here you could probably just say black, then white, have a couple of sliders. My issue is you're not seeing the value, right? And the issue with black and white is and if you display the value, especially if it's an integer, it's huge. So we could display the value underneath though. So we can have black, white, and then the value literally gets displayed underneath the slider. So maybe, I think maybe that's sensible. Yeah, okay, so we'll design something like that. So let's just get the black one in. Click. Hey Drots, how's it going? I like colors. Glad you like colors. Undo. Not gonna lie, I think it's like Temple OS. I think you're like the 3rd person or maybe 4th person now to say that. That's cool. Appreciate it. Yeah, right now we're just we're not really caring about how stuff looks, especially when it comes to 2D interface. It's all about functionality right now. But yeah, we're just making sure that we can it's all about functionality right now. But 2D UI can just be themed. Before I do any more UI other than this, until I do some more UI, I don't really care about theming. Because the problem is if you change the theme, and I've built tons of UI, I've got to make sure that all the other UI changes with the theme. So I think if we build any more UI other than this texture viewer, then I want to focus on doing a proper theme. But until then, I think we'll live with, maybe we'll make it more kind of dark mode that doesn't flash our eyeballs. But yeah, I think actually after we've done the texture viewer, we're going to be working on like PBR materials. So we're going to make this all PBR. So I guess we're going to put all of our focus in making 3D look good. Because we want to, focus on rendering. That's really green. Green? Yeah. So basically, I picked those colors on a screen which is not color calibrated, and that's where we are. Yeah, it's gonna be a lot of maths. Yeah, I've been doing the research on it. I've been watching lots of videos and reading some bits. Um, so yeah, we're gonna be implementing that. It'll be fun. Um, but yeah, I think we'll start off with just getting a single sphere looking good, PBR, and then probably do a cube map, do some image-based lighting. You saw that free PBR book? Yeah, I've seen it. It's quite meaty, not gonna lie. It's got a lot of stuff in it, but there's probably just certain sections I can read. Um, but yeah. Yeah, it's a good reference, I imagine. Thank you for dropping the link. Yeah, you can buy it in physical form, isn't it? Or you can just read it online for free. But yeah, he covers like all the prerequisites, right, of what you need to learn. Um, maybe I should give this a read. Problem is, reading this on my phone is like not. Yeah, I don't really have many places where I can sit and read for long, and that fits into my schedule throughout the day. So reading is basically out. I read on my phone a bit sometimes, but yeah, it's cool though. Should probably read some sections of it, not gonna lie. This is the peak of graphics programming, I think. What do you mean, like whole what PBR or the book? Yeah. So I need a slider. Yeah, PBR is pretty good. The way that it just makes stuff like look and feel better. Yeah, I don't know what the look I quite want to go with. Um, but yeah, I think if we map from 0 to 1, if we have a value from 0 to 1, we can always map that into anything. So I think we need a view mode. Right. So you have a black-white value. As long as you think it'll take for you to start. Not too long. Like, I'll just do the most basic version first. Like, I've seen... Yeah, the thing is, after that, I want to do, a BVH construct. Do a second attempt at making a BVH with the new LOD system. And then do GI. So that is going to feed into, like, PBR nicely. Yeah, PBR shouldn't take too long. It might only take a couple of streams or maybe 4 streams if it and do an optimized version. BVH, a bounding volume hierarchy. So it's the acceleration structure for ray tracing that you basically use. I did one before. Hey, Mad Flash, it's been a while. How's it been? Been a while. Yeah, still mod. I don't know, I've not dished out mods for a long time. No, you can have the sword. Keep the sword. Yeah, I've never seen it too. How dare thee ask for unmod? Right, so that's kind of nice. The issue is we need we want to display underneath the actual value or somewhere. And depending on the view mode, you see a different value. So cut left, center vertical, interesting. Right, so A should be cut. C, cut top C 20, and I want to display the text in C. I want to display right, I need to do a custom format. Probably just 32. Well, not even that, just like 16 probably. I think that's right. Yeah. SN printf buff size of buff. Chuck in. It might be U or F depending on the view mode. But let's just do U for now. U would be tab black multiplied I know. Right, and convert that back into a... Okay. So we're gonna have to say if the view mode equal to GPU view mode int else it's floating point. So cool. So then you would display the value here. The string is buff. Right, so let's see how that looks. I streamed so late. What country are you in? I guess you're in Aussie? Right, so clearly that's not enough room to display that line. But yeah, the value's there, it's nice and long, it's good, but like, we ain't got enough room. So let's up this to 80. Let's give that 40. Maybe not even that, just 20 is probably right for the text. Why this ain't got enough room? Means bottom of A. Huh? Shouldn't that... Let's not display the text there, see what happens. Bit weird. We had... Don't we have slider things here? I'm a little confused. Why is that not wanting to work? That draws the bar. For the grip. It's meant to say horizontally, but anyway. Oh no. Same vertically. Let's hop into the debugger on that one. Core breakpoint. Asia. Oh, okay, yeah. From the future. You're in the future right now. So you're like +8 or something like that. But yeah, I stream in the evenings UK time. Basically, it's going to affect somebody. So yeah, I think people who are Asia or ahead of me basically suffer the most. So Europe isn't so bad. So do the drawing. Height is 52. 26 is her half height. It's 4 pixels big. The Y is 0. Oh no, 4 pixels still. And does the draw. Should be there. And it's opaque. Opaque enough. Right, maybe I just need to give it more height. I thought I gave enough height, not gonna lie. Make it 120. Why isn't this thing showing? It shows here on the background. Here, these things show, right? How big are these? Are they cut? I think they're cut in 200. They only cut top 50. Is my box style not good enough? It's a copy paste of this one though, isn't it? Yeah, we'll be using all the same stuff, I think. This is copy pasted from there. Something's wrong. Right, it's definitely not showing up anymore. Okay, still. Should we say don't render a background for this thing? Let's use the no box style. And let's see if it shows up there. Okay, it's showing up here with a background now. Without background here. Oh, it's the same color. That's why. Right. Shouldn't it be using the foreground color then? Foreground color. Right, it's showing white. That's okay. We can live with that. It will do for now. Right, so black and white value, you can tweak it like that. Good. So we should center this text a bit. Easy peasy. C. center horizontal. C. Well, it's easy when you know this length of the text, which you do here. So it's text width times by 20 pixels. Magic numbers everywhere. Here we go. Future Henry's problem. Right, it's centered now. Ish. Well, no. It's a bit better. Yeah, it's interesting. I don't know. I think I have a very... Yeah, it's very strange compared to just other channels. It's quite quiet usually, but I guess people don't just distract me. It's quite fun, quite funny. But yeah, I think people working on their own stuff too. That's right. Mixture of things. It's kind of centered. Maybe it's off by one because it's a null terminator. Yeah, null terminator. I think it returns. No, it never returns the null terminator. You always add one for the null terminator on sprintf. I don't know why it's off by one, but anyway, that's all right. So we look at the integer texture, which is this one. And then one, okay. Yeah, that's not great, is it? Well, that slider, that you can barely view your low values. So you probably need to combat it with a square, by squaring it or something. Maybe like if I squared this result, the value will look better. Yeah, it has more of the low range on it now. It's a bit better. So yeah, maybe it's... So the problem is with the slider though, how do you... I'm squaring it here, but you want it to be kind of in squared space in the slider itself, like when you slide it around. Yeah, like when it reads it and writes it back out, you want it to be square. I guess we'll just square it manually in the shader. If you went. So we just square it there manually. I think that's alright. So now we should plug it in soon. But let's get the white one. Put out the white value. So we see black replaced with white. Okay. That's an old Windows game. Yeah, just currently doing, you know, just really ugly theming. until we get some good graphics. I need to write tons of UI. Do you still work at that company where there's like 50 employees? There's like 100 employees, I think. Somewhere around that. Give or take, I think. We started dreaming what each other. What? Start streaming and watch each other. Yeah. We should get like 7 monitors and watch everyone else at the same time. It could be like, you know, an online Code Royale. Massively, yeah. I usually chat when something breaks with the spec, edge cases and stuff. It's nice to see the problem solve passively sometimes. Yeah. Yeah. Yeah, I think when I'm struggling, people like chime in, especially with maths. Like when I'm struggling with maths, people will chime in. You get all the mathematicians come out. It's good fun. But yeah, oh, I'm not sure how people handle really active chats though when they get like really high. That's an insane skill. It's an insane skill. Okay, so the white value needs to default to 1. So at the bottom here, when we initialize the GPU system, oh, the tabs. So whenever you add a new tab, we need to initialize it to 1 as well. White 1. Right, so if we view that now, we should have, yeah, so white is 1, black 0. So just got to plug these in into the in the shader. So when we view this, it'll be a lot nicer. Be controllable. So in the shader, we don't pass them in yet, right? So we'll do that. Right, so F32 black, F32 white. How many of these do we have up to? Yeah, up to 16 of these. We've got plenty for the push constants. Oh, right. So inside the actual, I need to close stuff that I don't need to open. That can close, and that can close. Right, so in the actual shader now, we've got this controllable black-white value. So the depth one, right? You get your depth value, depth, pixel.r. Now, you apply the actual. So I think you take with any range thing, you need to remap it from. You're remapping it from black to white, where black is 0, where the black value is where 0 turns to 0, and the white value turns to 1. So when you do those conversions, typically you take away the min value, and then you divide. Is that right? It's divide, isn't it? You divide by. So you take away min. So now this is from 0 to white take black, right? So then you do white, which is the bigger number, small number will be black. And then, so that will then get you the 0 to 1 value. Cool. And then you can poke depth into here. So this is only for the depth, obviously, but we need to apply that to the colors as well. So if we see this, not the surface, see the depth texture. So, right, I don't think that worked. Oh wait, no. Right. So for depth, we want it to be probably up to about 1,000 maybe. So 0 to 1. Yeah, so I want to make it go up to, I don't know actually. What should we do for a depth value? So I wonder if we should store, we should have different ranges and just store that. Yeah, maybe we should just use the floating point value. So maybe based on the viewing mode, we should have a bunch of min-max values. Like default black and white, perhaps. Yeah, maybe that's alright. So you probably want to have a black value and a white value. Default black, default white. Is default black always going to be 0? Probably. Maybe it's good to be explicit about it anyway, just in case. 0, 0, 0, 0, 0, 0. Only KDE is acceptable terminal emulator. Use Emacs to be professional. C, not safe. Use Rust instead. Hello. Whoa, that's a whole load of opinion. Hey. Yeah. What are you? Gen Z? I'm doing alright, thank you. Just ticking off a lot of things to do this texture viewer. But yeah, we're doing pretty good. Doing pretty decent. Just finish off this black-white range thing. And I'm going to view individual RGB color channels. And then going to do hopefully some tabbed UI. So yeah, doing pretty alright. So black white. You know, I guess you could clamp you. No, I'm not doing that. So these ones, we could probably just use an infinite. Probably negative infinite. But then like, yeah, I guess these are just completely ignored. Actually. Yeah, I think these are going to be actually completely ignored in the shader. but it's good just to have them there anyway. Huh? Alright. Color. 1? Well, you might want to be able to go higher than 1 in linear space. That's for sure. But yeah. Depth, let's say 1024. This one. Okay, so I think we have these. Should be. So whenever you change the viewing mode, the black-white values should get changed too. So when I've selected, yeah, so view mode equal right, tab, black, whatever the view mode is. So you get some sort of default, oh shoot, view mode. Okay, so black or white value is selected there, but then also you can change the view mode in a drop down. So there's a combo box for that. It is here. So this one says to you if it's changed. It's just a Boolean. If it's changed, reset the black-white values. So okay. I wonder though. Right. Let's delete the white one, we'll recreate it again. So in here there's like a min-max, right? Maybe we need a separate min-max as well. So perhaps there is a black min and white max. Sorry, your max should be where the white value is. Right? And then when you make the white, your min would be where the black value is and your max would be max white. So that right, it's in the internal header. Let's go and add those boys and girls in. So we actually want to add, so you have some defaults on those, min and max. Should be quite handy. Well, you might have 0, 0 actually on the other ones, maybe. Alright, let's copy paste these. Default, min, max. Okay. So oh shoot, I was gonna, okay. So min and max on these are actually negative, negative. Well, they're not really used. So maybe they should just be faded out. Yeah, maybe we should just fade them out. Alright, one more. The other one will be black, white, supported, Boolean. That one will be super handy. To just basically disable it. So it's not supported, supported for color, supported for linear color, supported for depth and supported for int. So these, I guess, could just be 0. 0 and 0 there for the default white. Black min. These can just be 0 again because they're not used. So for the black, the minimum color is 0. Minimum linear color is 0. Depth min is 0, and int is probably 0 too. Okay, probably all right. Max color will be 1. Linear color, it can actually be quite high. We probably want to work. Yeah, I don't know. You can have quite maybe 100. Maybe let's just say 1 to 8. You probably have much higher, but let's just keep that for now because it's draggable and it's easier that way. So we'll solve it properly later if we store any sort of like radiance or whatever inside a texture. So the light would be in a linear color space, wouldn't it, as well? Depth. Let's just say 1024. Right. Okay. Maybe you can have higher depth. I don't know. Maybe that's fine. So now we've got those extra things in. So when you're using this slider, yeah, maybe you don't need to be in squared space anymore. Maybe that's fine. So you just need to view it as a float. Okay. I think that's fine. So we just repeat that and let's look for black and then replace it with white down here. So the min value for white needs to be black and the max value for white needs to be white max. Okay. Is the music still going? Bring back the music. Here we go. So here's the depth texture. Something's still not right there. We're getting the values correct here. It should never be able to put in the exact value, maybe. Right, where's the depth? Right. Oh, we didn't pass in the black and white when we called the shader, did we? Let's do that now. So that's in dispatch copy. Yeah, we didn't simply add it in here. BC black equals tab black and white and then white. Cool. So now they're uploaded to the GPU shader via the push constants. Depth, here we go. So now we can drag that and then drag this. Sweet. So maybe 1024. Yeah, maybe I think that's the maximum depth anyway. So if I were to move the thing away, it's really annoying with this. But yeah, I can basically fade out the stuff from far away, right? And fade in the stuff that's closer and make it more black, basically. So that's super handy. But also it applies to color, where we can change the black levels. Oh, I haven't actually done it yet. Here, sRGB. So we want to do that here as well. We're going to apply the conversion. You know, maybe we just do it all down here. Crap. The issue is not all of them have it. Wait, that's converted it to... Yeah, we'll do it manually. So color dar GBA. Do you want to do A? A is alpha. But then we'll just make alpha. Yeah, alpha's linear, but we'll be making it 1 anyway, unless we view just the alpha channel, which we're adding soon. I think that'll be okay. Then here, that is white. So essentially we'll replace this with ints. Ints casted as float 32. Right, so let's have a play with these and just see how they respond to this black customizable black-white value. And I think we can just record another devlog thing, right? So sweet, so that makes them more, we'll bring the white value back, which means we'll make it more, the darker ones more bright, and we bring the black value forward, which means we make the lighter values darker, right? And you can never drag this thing before the other one. Cool. Right, that's good. Awesome. So we can get rid of yeah, we can find the brightest points quite easy, and we can, I guess, but yeah. But yeah, at least that's useful across multiple domains there. Here's the occupation map. It's an integer. Here's the integer here. It's been printed out. It's a bit big though. But yeah, I can bring, so each 32-bit integer is a 4x4x2, where each bit is a cluster that is fully filled with spheres. But yeah, I think this suffers from the problem. This is still, it feels linear. Sorry, it feels exponential. We want it to be linear. I want it to feel like it's linear, but it feels very exponential. How do we want to solve that one again? So we used to just square it in the UI, but the problem with that thank you, that's what white looks like, right? But the problem with that was yeah, we don't do that anymore. It doesn't work that way anymore. I think it could be the way that the slider code is written. So how does it do when you click it? How does it give so it's like a range thing. So if it's a float, we do an end take start. Yeah, we do this similar sort of thing value clamped between the start and the end, right? Start point, end pointer? Is that like a min-max? Oh yeah, min-max value, start, end, yeah. Yeah, so we pass those in manually. That's fine. So we clamp it between there. Get a range. The bar width by the range. Okay. Yeah, so I guess it's just the nature of the way floating point works. With the precisions and all the low bits, maybe. Maybe not. No, it's not. It's because I want this to be the square root here. I want it to behave as square. Where does I stick the square root though? But yeah, you want it to probably square root it. I guess this is okay now because I don't see myself using this for the int one. But if I did want to use this more, I think we're going to have to make this better. But yeah. Although we should go back probably to saying if view mode equals GPU view mode integer, I do want to make sure that we do a .0f. So I could have a format lookup for each of those view modes maybe, for the black-white coloring thingy. Maybe that is the way. Yeah, maybe that's the way. Let's add one more, and then we're done. Black-white format. How do you view it? Should be pretty nice. So 0, we don't do anything. I guess you could pass in null, really. Null. Color. .3 is probably enough. Then depth. Kind of 2 decimal places is probably enough. And then int 0 decimal places. So, right, we want to disable if they're not supported also. Okay. So the format goes there. So that'll be view mode, BC view mode. Then we also want to, not BC, what am I doing, tab. BC would be if we're inside the shaders, right? So then we say UI disable scope. It is disabled if GPU texture view, oh shoot, I got that bit wrong. Is, okay. This is named slightly wrong. View mode. All right. So view mode, so it's disabled if is not supported. Isn't it supported, right? Yeah, black was supported, okay. If it's not supported, it's disabled. And there we go. So let's try and have a look at those. Sure. So if we look at the depth texture, well, this sort of slider now, right? If you change it to this one, oh, no. The seg fault, no one gets that in C. Oh, it's still running it anyway. We should pass empty string then. What the hell did I just do just there? Okay, I moved the mouse. Yeah, so white if any component is non-zero, one if any component is non-zero. Why is... I think that's broken now. Whole thing should... Oh yeah, the depth... No, that's fine, that's fine. Wait. Let me double check that. Okay, it's still fine. Yes, they're faded out, that's good. Color 0 to 1, linear 0 to 1, but can go up to a very high value. That's not very nice. Maybe this needs to be another square rooted value actually, but again, it's a problem we can solve for later. Yeah, that's really cool. Happy with that one. Hey there, Drevisted. How's it going? Good evening. I'm pretty new here. I also like C language a lot. It was a language I learned programming with. Cool. That's pretty. Yeah, exactly. Lucky you. Lucky you. Yeah, I learned with JavaScript. But yeah, that's cool. Have you got any little projects you're working on with in C or any? I don't know. You do much of it at the moment? Right. That's pretty sweet. So we've got that one ticked off. I still need to record a segment though on that one, but we can tick that now. We're getting close. I think, yeah, so we just need to do view RGB colors independently, channels independently, and then we do tabbed UI. My loss? Well, my JavaScript loss? Nah, it's fine. Past Henry can disappear. Right, I'm just gonna take a quick break and then we'll be back and sort out the final feature. Right, I couldn't help myself, but I got another Pepsi Max Mango. Didn't just fetch water. Oh, it's gonna be good. No project you can see right now, I'm all into web dev with JavaScript at the moment. Beautiful. Fair play. That's cool. Come back to the seas though. Yeah, VOD channel. Yeah, VOD channel, Discord. Also YouTube channel where we post devlogs as well. Boom. So we recap all these streams into a devlog. So that's what we record. When I recap, it will get stitched into one video. Usually about 15 minutes long or less. About 10 to 15 minutes, 10 to 20 minutes. Oh. No, that's good. So what is the thing? So we have to, we want to talk about this piece of code, I guess. It's just UI code. But mainly we want to talk about these arrays probably. We also want to show off the actual, you start off with the UI. Sorry, we're actually using the black-white thing, showing what it does. Then we can go into the shader code. We can talk about how we, don't use it for these two, but use it for stuff like these guys here, right? Oh, the linear is missing. Missed the linear. Then all right. That's cool. So cool. I think we got it. We're gonna nail it. So let's go and do it. Okay, so we've gone and added this sort of black-white value thing here, so we'll be able to change where it's deemed as white and where it's deemed as black. So notice here, as we move the black value forward and increase it, the thing which is deemed black gets further and further away, or more things become the minimum value basically. Black is minimum, white is maximum value. So typically it's 1024 where the maximum value, where all the stuff fades out on this depth texture. As we bring it, make it short so things fade out quicker and quicker. Now this is not just for depth. This is also for colors as well. So we view the surface and view the tiled ray tracer output. You'll notice here we can move the black value so the darker pixels become darker, and all pixels become darker and the darkest ones fade out quicker. And then the light one, all pixels get lighter and the lightest ones become lighter quicker, right? So very, very useful just to sort of, or as another tool to sort of help understand images, basically color or depth. So yeah, there's that black-white feature. Let's go and see some of the code and how it's implemented. Cool. I'll put another marker here. So we're going to start off in the shader code. So this is where we do the texture copy. So we take a pixel and we interpret it into some other value, some color basically, and just put that into a texture somewhere. So if we're viewing it as an integer, we reinterpret cast the pixel into from floating point into a bunch of ints, and then we will actually cast it from an int to a float, and then take away the black, which is the min value, then divide it by the range from going from white to black. And do the same thing for color and linear space, but we don't do it for this one if non-zero and white if non-zero, because these don't really have a min-max value that we care about. We also do it for the depth as well down here. So as an example, right, white is 1024 and black is 0, right? Well, okay. Say if it's 24, right? You're taking away 24, so this will either be minus 24 to 0, right? And then you're dividing this by 1,000, right? Because you're taking 24 away from 1024. So this will be from range basically 0 to 1. It might drop into the negative, but that's okay because it just cares about colors greater than 1 in the final color anyway. So yeah, let's take a look at some CPU side code now. Boom. Is computer science going to be viable for 4 years? Everything is viable as long as you want to do it. Like, there's also computer science and computer science. Yeah, well, like you do things because you like doing it, you know, so it's viable, right? People want to make, become a blacksmith and make weapons and armor. They can still do it. Viable. Like if you're doing computer science to make money, like there's plenty of other things you can do to make more money. You can be a doctor. You can, there's plenty of ways to make tons of money. That's not computer science. Exactly. I was gonna stop me from programming. You could pry my keyboard away from my cold, dead hands. Yes. Yeah. Yeah. Human-made software will be a thing. We still don't know how good this AI technology is going to get. It could replace everybody. It could not. Knowing human beings will jump on something too early and it will be catastrophic to a range of things. And the humans that are here still, that can still program, will save the day and get paid tons of money. That's one way it could go. So you never really know. I have pursued computer science, was specializing in cybersecurity. It's been 2 months. I'm just in college, just asking. Sure. That's cool. But yeah. Cybersecurity. Yeah, I don't know. Maybe not. We don't really know. I think AI is going to be really good at finding issues, like help a human find problems that are that require very machine thinking. Machine-driven thinking, stuff that machines are good at doing. But I don't know. Yeah, we don't really know yet. Just gotta wait and see. Right, so what was I going to talk about? These things, right? Okay, so I've added a bunch of these arrays. Actually, no. Right, okay. Okay, so obviously the shader gets past these black-white values up from the CPU. So CPU side, each tab holds a black-white value that it remembers, and whenever we try and dispatch a copy of the texture, we pass in the black-white values from the tab into the shader. So CPU side, we have based on the view mode, we have a bunch of these different arrays. We say, is this black white value thing supported? Because it's not supported for all view modes. What is the default black value? What's the default white value? What is the min black value? And what is the max white value? So these are some lovely little arrays where, you know, and also like viewing the black white format as well. Like how do we view that number in the UI based on the thing? So for linear, it's 3 decimal places. For depth, it's 2 decimal places, and for int, it's 0. And you know, we have some default values which are a bit different. Depth is like 1024, and colors are like 1, and they have some different max values and stuff like this. So, you know, in the it's just using our UI code, right? So we basically have black and white. Wait, where is it? Black and then white. They are disabled if they are not supported. And essentially we pass in like the format here when we display the text string. And then, you know, the min value of black is black min, but its max value is white. So we don't allow black to be greater than white and white to be less than black. So the white is basically the same thing, except for the min max values are as we just said, right? So that is the black white filtering options. Cool. So I'm glad that's in there. That's good. So we can move on to the viewing individual RGBs and As, because we can't really view A right now. So yeah. I have an interest in coding. That's why I've got into this field. Let's see what the future holds, I guess. Oh, so you're interested in coding? So you're doing computer science specialty of cybersecurity. So why are you not doing programming then? If it's why you got into the field. So if you're at uni, do they not have a good programming course? Or would you want to learn? Yeah, not sure. Right, so to view individual RGBAs, so let's take a look at RenderDoc quick. So RenderDoc, it has, so view like the final texture. So I think they have this, yeah, range as well as black white range, right? They have this too. It's a bit different than ours though. Oh no, because we didn't have this UI there. So they also have here, this one I'm looking at. So if you get rid of B, it just gets rid of B. But you just have 1, it makes it white. Okay, so you can just display 1 or 2 of them. And then this means you can display alpha. Now, alpha, when it's displayed, mixed in, what is that? Oh, you're seeing the color, the texture behind. Okay. So I guess if you can see the alpha. Yeah, so I think what we'll do is we'll have RGBA, individual sort of things you can toggle like that. What is this? Background color. Right. Oh, interesting. Or you can display as a color. So yeah. So I guess we'll just do something similar like this. Yeah. Do something similar to that. That'd be good. So we've already got this. Boolean. So I could do as a bit set already. So we've got this thing called like color32, color chan, color R, is that right? You know what, just yeah, color32 chan R. So these are 0, okay, 8, 16. I guess we could use those. We could also just have a new enum. They could go in the flags. Yeah, no, let's just use these color chan things. So the problem is, yeah, that's right. So we just have it like visible channels. Color chan star. So inside the user interface, when we do so where's it gonna go? So we'll default it probably to all things on, but inside the UI, like, do we just stick it at the top, like just channels? You just click them on, or do we put them here? There's just gonna be a bunch of toggle buttons that you can just click. So I could just say channels, and you just click them all, right, or up here. I could put them above MIP maybe. But the interesting thing is, depending on the format, you only have certain color channels anyway. So you can kind of know if someone's got an RGB array, maybe. I don't think that matters that much. So when you select a new texture or whatever, you're going to say visible channels equals color 32R, chan R, be, sorry, RGB. There you go. Okay. So when we're in, I guess we'll do it just by the above the MIPS, right? The first one, so above the separator. We're going to cut from the top, and then from here, we're just going to do a bunch of cuts on the left. So we cut left, and then say show channels or channels. So no box style, do a cut on the left, please. Awesome. Then the next one we do a cut, and we're going to display R. So it'll be a toggle button. So we have Boolean, ball, is, let's call it show or whatever, I don't know, words. So it's a show equals tab visible channels, and so we're going to cast the result into Boolean, and visible channels color 32 chan R. Sweet. So Yeah. Okay, so you just set that right, and you would do a cut left, and you want to use we've got a thing called a toggle button, right? Toggle button with a bit of text. So that is a rectangle, which would be B. Maybe you need to cut left by 30. 32, something like that. Is checked show string. So I need to use the C one. That'll be R. And voila. So here we're going to use the box style, and then we're going to make sure that we store back. So we make sure that we and equal the not of that, and then we or on it the based on whether show is if show is around, if not, yeah. So we just repeat that 4 times. So look for capital R, G, 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 G. Look for capital R, B, 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 A, 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 A. So now we look at that, the UI should all be set, and we should be able to flip those boys and girls on and off. So apparently I didn't get the width high enough. We've got such a big radius. Maybe we should reduce the radius actually, because the radius is a bit too much. So let's say 4. Maybe 4's too little. Maybe 4's fine. Just a nice little radius. No. Maybe 8. Oh, scroll bar radius. Okay, let's try that one out. Right, that's a bit better, I think. Okay, so we're seeing them a little bit more now. Some reason, yeah, channels didn't cut enough. I could just call it Chan. Nothing wrong with that. Channels, Chans. Right. So there's your channels, RGBA. They need to be a bit wider. Too much border and all that. But yeah, theme can be addressed later. Not the issue right now. So let's say 40. But yeah, so apparently the G, B, and A are on, but R was not. They've all got the same values for some reason. What? Have I not tested the toggle buttons out yet? Thought I did. Should be okay. So they're all different values, right? They all fit within a 32-bit int. They're all on. Why is R? Okay, what have we done? So we've and knotted R. Ah, 0. It's a 0-bit, damn it. Whoops. Then that's 8. Yeah, that ain't gonna work. So we probably need our own. Yeah, that's 0. That's 8, 16. So, whoops. So maybe we just need to one shift left it. So yeah, I guess we'll just say. It's a bit annoying though. G, B. Right, bit R. There you go. So all of this is bit R. All of this is bit G. All of this is bit B. And all of this is bit A. Cool. So right, so your RGBs there, those should all be on, but they're not. But they're toggling. So I think we didn't. Yeah, I think we didn't. Right, and one shift left it all. Right, one shift left. Sweet. So if we try that out now. Kill all. Right, here we go. So RGB are all selected now. They're toggling fine. So now we get to wire this in the shader code. The visible channels needs to be, so in shared, you need to add another one. Call it visible channels again. Now visible channels, it needs to be initialized in the dispatch copy shader. So we need to take it from the tab again. Visible channels. So the push constants gets that from the tab. Then in the shader, we now need to only view the certain one. So where does it go, right? Do you do it before or after? So the thing that's interesting is if you do it after, you've already made a new RGB, right? Based on how you've converted the color. So I think you want it before, right? You want to say, no, don't before. But then again, it's like, yeah, so I guess you're just going to 0 anything else that's not shown. I think that's right. So but say if you had like, say if you packed a lot of information into a texture like a gbuff or something, and then you use the view mode to then pull out a certain RGB color, right? Maybe you only view the R component of that. So maybe it does make sense to go afterwards sometimes. And realistically as well, with these color ones, you're not really doing much with them. You're just converting it to sRGB from linear. Wait. Yeah, from sRGB to linear. Or, you know, you're just applying this sort of black-white thing. So I think you should go after. Yep. So here, you're going to say if BC visible things, and so if it's not got red, so I think what we want to say is like if you've just got one of these set. So there's like a count bits. Bit count. That's it. So you do bit count. If one of them's set, we're going to make it black and white. Yeah, grayscale. So BC visible channels. If that is equal to 1, then else we just do a whole if chain of if not BC visible channels and 1 shift left color 32R. So if we've not got red, then make sure your color.r equal 0. So we just do that. Oh no. What are these? Oh, they're in core. Excellent. So we just didn't bring in core here for some reason. Core shared. Huh. Anyway, I think it should be fun. No. Shown. That's annoying. That needs to be... Why isn't that being shown? Compiler flags -I source. Yeah. Should show up. Damn IntelliSense. Well, we'll see if it's a compile error in a sec. Maybe it is a proper compile error. A0, B0, G0. But A doesn't really matter. Okay. Because you want it to always have alpha of 1 when your output. So here, this is where you do the... man, yeah, swizzling could be interesting as well. But yeah, I think we don't need swizzling. We can always add in if need be. So now we say, well, if it's just 1, what we want to do is get all of them, or it together, and then splat it out to the XYZ or RGB components. So basically we're saying color dot XYZ equal so you get visible channels, right? Wait a minute. Wait. Ignore me then. You don't want to do that. That doesn't make any sense. So you want to extract the RGB array out. So you have value. So make that equal to 0, I guess. So you say, if I've got any of these, value equal color.r. GBA, then color.rgb equals the splattered version of value, and then alpha is always 1 anyway. Right, I think that's it. So let's compile that. Right, I can't actually find it. Why? Let's check my file system. There it is. Why is that? Oh, whoops. Oh, that was the macro. Chan. Chan. Sweet. Cool. So let's run that. And, oh, hey, hey little man. Right, so we should be able to view. Right, so if we get rid of red, it's gone. Get rid of G and that, it doesn't matter. Right, that's cool. Now let's go to color. Right, here it is. It's only got red. Go to red, it's gone. Right, but I can also just display the alpha. That should be displaying some form of alpha. That's wrong too. Wait, if not visible, whoops. We should say if it is the visible one. Damn, Boolean logic. I wonder why it wasn't working. Okay. Right. Surface. Right. So we turn off the. If we only display R, it becomes black and white, right? Grayscale. But if we only display A, right? I guess they've all got the alpha channel set. No, but we explicitly made it 1. Here, shoot. So you want to explicitly make it 1 here always. Let's try that out. Right. So tiled ray tracer. Excellent. Amazing. So now it's in the alpha channel. Cool. Super helpful. That'd be great. Yeah, so as we get more color on the screen, it'll be helpful to have that there as well. But yeah, you can see it working here. Nice. All right, so let's talk about that one. So we've added. So let's talk about the showed off first. Then we'll talk about in the shader how we have this. Yeah, and then we'll talk about how we've just done it in the UI, I guess. And then we can move on to tabbed controls. And that's the final part of the texture viewer. Let's make that a win. Ding. Oh, this is gonna be good. Getting close. So the best one to view is probably, oh shoot, we added a marker. Let's go. Okay, so we've gone and added the ability to toggle on and off different color channels. So in this example, we've only actually got red on the screen. So we turn off the green and blue, we're not going to see anything, but if we turn off the alpha, you'll notice that there's only one channel selected, which is R now, and it displays it in black and white. So this is especially useful for alpha, so we can view the alpha channel individually by itself, and we can see here how this is very transparent, whereas these are fully opaque. That's one use of it, but also if we go over to view the surface, which is the thing that we render, so we're seeing infinite repeating here. This is obviously the UI. We can turn off the green channel, and we just see the red and blue. And we turn off the red channel, just see the green and blue. And yeah, again, you can only display one, and you see the green parts in white and black. So it's going to be a super handy feature in the future when we have more color in our scenes. So let's go and see the code and see how this works behind the scenes. Okay, so in the shader, at the end, after we've done the view mode translation, so we could have different view modes that put specific colors in R, G, and B, and I think it will be helpful to do it after those conversions. So if we only have one channel that is selected, we simply try and find that channel, and then we will store value in there, and then we'll splat it out to the RGB components. So this will work for an individual red, green, or blue, or alpha that's selected. Whereas if there is multiple channels that are selected or none at all, we'll simply try and remove the colors that are not selected. So if R is not selected to be visible, we shall remove that. If G is not, we'll remove that. And if B is not, we'll remove that also. So alpha in this instance, we don't have to care about it because we always make sure alpha is set to 1 when we copy it out to the texture viewer copy texture. And then simply inside the user interface, well, actually here, this is when we, obviously when we dispatch a copy, we'll just copy over this visible text, visible channels into the shader when it dispatches it. But in the UI, it's very simple, right? We essentially just have our text filter says channels. We get the bit that is on the RGB and A, and we basically just have a bunch of buttons which can be toggled on and off, and we just effectively have it on when that bit is on, and we'll remove the bit after the button is done, and then or on the bit if it still exists or not. And we repeat that for R, G, B, and A. Cool. That was great. So that's a bunch of features done today. We've still got one more feature I'd like to do. And then after this, we can move on to screenshots and stuff. So this is the final thing I want to get done today, tabbed UI. So we have a plan for this texture viewer. It's going to integrate screenshots into it. So one of the features that I want is to be able to, have a few tabs open, a couple of screenshots. I can tab between them and see the pixel change. Yeah, I want to be able to, I might be zoomed in a specific part and I want to just alt tab between the two. So realistically, we want a bunch of tabs up here. So we need a kind of like a tabbed view. Shouldn't be too hard to implement. Just got to figure out an API first. So we're gonna try and sketch that out now. Just bring open the UI. Wait, we kind of want to do the usage code. So so you need a rectangle. See, I wonder if it will need like a state thing like the split area does. Let's have a think about this. So say we have like 12 tabs at most or whatever. We could have a maximum number of tabs, which doesn't sound ridiculous, right? Because tabs are typically you're not going to have like, I know web browsers support like quite a big number of tabs, but it doesn't seem unfeasible in the project that we're working on to have a finite number of tabs. Inside the we have 8 tabs. So maybe our UI system just has a way of saying, hey, there's this many tabs at most. Or maybe it doesn't matter. Yeah, so maybe we'll just say, yes, I think we need a strut. I think we need a strut. So we're going to have to do something like probably a tabs count. Tabbed area, I guess. No more Pepsi. Yeah, Pepsi out. No. Yeah, I've had my 2 cans, so no more today. I don't want to be up late. I'll catch up on the water. Maybe we don't need one of these. Maybe we do. We need like a strut. So we definitely want like a number of tabs. We definitely want to have a tab index. So selected tab index in some way. We also want to have a name for each of the tabs. So I don't know, maybe we don't need a state thing. Maybe it could just be quite easy. I think it could just be a prototype. Because yeah, I think we could just say UI tabbed area or tab area start or something, right? And you would pass in an address to the selected tab index, so it'd be GPU texture viewer selected tab index. We already have one of those. Then you pass in the number of tabs that you have open. There's a number of tabs. Excellent. And I guess you can have a button to say, I want to open more tabs. As well. And I guess you need some form of style. So when you start your tabs area, you have to populate. You have to do a for loop over all of your tabs and do something like a UI tab header, and you have to say, here's my string for the tab. So you would say, you put the name for it in there. So in this case, we will get the resource, which comes from GPU texture viewer tabs index dot resource, yes, and that'll be GPU resource get. So then you would get resource debug name, right? And I guess maybe you might want to display like an index. Maybe All right, let's bring this out a bit more global. So I think we want to make a a thing in here. So you might... The thing is about these tabs... Yeah, no, I guess they'll just be evenly divided. They could have some max size somewhere or something in the style maybe. But yeah, I think that should be okay. So you just say snprintf into buffer, the standard, throw it into there. We'll put the tab index in here, followed by the name of the resource. So so we'll say like index and then resource debug name, and then we'll throw in there the buffer, right? So I think, yeah, I think that's good. And then from here, you would just have your rectangle. Oh, wait, where's the rectangle? That didn't go in. Rectangle, you would get rid of the line for where the tabs are at. And then the tabs. So we'll need to add 2 more style things, I think. Like no, maybe it could be what's automatic actually. Yeah. So the only thing we're missing now is so this can go, this is done. The only thing missing is probably adding a new tab, right? So luckily, well, there is this thing where it says is visible. I guess we just always assume that it is visible. And what you want to say is there'll be a UI new tab. And you want to say, okay, if new tab, then we will allocate a new tab. But the issue is we have like a maximum number of tabs. So and the problem is as well, if you do it here, you would have gone over all the old tab. You pass in the old tab count, so maybe does the inside up the number of tabs, and then like your maximum number of tabs. So maybe you put a max number of tabs in here. It gets quite long though, but this could be the way. So it only got quite long because my variable names are long. But yeah, so if I say GPU texture viewer tabs capacity, and I guess that's another one we pass in. So I think that's reasonable. Then in here, you can up the number of tabs by 1. So you would just say tabs count plus equal 1. There is right, you would need to change this as well. Let's go here. It will become the new selected tab also, and in that case, everything's going to be kind of. We should probably. I guess we zero initialize it, and also, how do you close tabs? Yeah. We didn't think about that. Say if I end up closing a tab, I need to swap the tab date. I need to swap remove it, right? Or so wait, it's a shift remove. Yeah, I need to shift remove from the array. All the tabs that come after, I need to remove those tabs. So how would I? Right, so I guess we do need a structure because it's just getting a bit fiddly. So we need a strut, and that's okay. So let's bring that back. So the way it's going to work is be this thing called a tabbed area. You're going to pass in, hey, here's the number of, or here's the selected tab index. That's a pointer. So that'll be mutable. Wait, Where's the in-out stuff that we do? Here we go. Right, so that's the thing I do, in-out. Okay, so this is in-out parameter. We then have an right number of tabs. I guess this can be mutated now. This is in-out. We also have a capacity. Capacity, that's just an in parameter. We also have probably a couple of booleans, right? Yeah, a couple of booleans. Is new. So is new would then mean the selected tab needs to be created. Out parameter, you say dash, means selected tab index must be initialized. Okay. Then remove. And if you remove, is removed. Out parameter means that it must be shift removed. Okay. Sweet. That's actually pretty good. So let's just get that ready, and then we'll talk about it. Tabbed state. So a lot of this stuff we could probably just set every time. Just zero initialize it, like so. Then we want to make sure that we actually initialize this stuff properly. So this will be something like this. Tabbed state dot tabs count, tabs capacity. Cool. Is new, and all of that, those are purely out parameters. So those will be set when we call this function here. So this, I guess, can return an is visible. So that would mean if this is visible, then, so I guess we can do that. So we'll pass in the rectangle still, we then pass in the tabbed area state, and then the box style. So that's just a lot easier to work with. So if the thing is visible, will anything go on? Guess we get a selected tab there as well. Cool. So, all right, how do I get this working? Or looking? So I've got to write some prototype stuff. So I'm going to write all the prototypes for these, and then we can go ahead and record a thing and then implement those. So void, not void, UI chain visible. So returns true if visible. Tab area start ID. So that would be a UI ID. Then the rectangle, followed by the tabbed state. I usually call that something state, don't I? Yes. Tabbed state. Split area, split state. Okay. Well, I guess we'll go with that then. state followed by the style, which is const UI style. So that is 1, followed by a define, which automatically does the ID. So rectangle state style, rectangle state style with a line. Line number is the ID. If you want anything else, you can do it manually. But the line is good enough unless it's in a for loop. Cool. So do a start there and we're all good. So we just need an end, void, end, void. And now we just need the header. Hey there, Wajilla. I've been debugging this for a while. My validation layer is throwing errors when I try to add to the next p chain of device features 2. I made sure this is supported by GPU. It says, even says it should be supported. What sort of error is it throwing? Is it throwing something to do with pipelines? I wonder if it's supported. Vulkan shader object validation, because it's been out for like 3 years now and they made a whole point of saying like it's usable today. So if it's not officially supported by validation layers, then that's weird. Are your validation layers up to date? Because validation layers are essential, and if you can't have validations on, then Vulkan's going to be even harder. Yeah. Right, so it seems like they have been working on it. So it should be fine. Yeah. No, just huge one about what I can and can't do to the P next. Oh, okay. So there's only a certain place where that can go. So I guess you maybe have it on the wrong structure. Maybe you don't, right? Maybe there's something else. Right, P next to physical device features 2. Okay, do you want to send a screenshot of the code that does the P next chain stuff? And I'll take a look at it, because you might have got something wrong with the pointers wrong, maybe. If structure is included to P next of device features 2, yes. Pass to... What the crap is this? Oh, yeah. Is filled in whether each correspondent is supported or not. Right, so this is saying... So are you doing this, right? This one is saying it's passed. So you initialize it, you've got to make sure you set the S type. So if you set the S type, you know what I mean? Yeah, I guess I'll wait for your screenshot. But basically you want to initialize this with the S type as the correct structure type, where it's like VK structure type, physical device properties, whatever. And is it preset in the Java button? It's nice. And then the P next. And then you call the get. So does this succeed? Does that error? You send in the Discord. Sweet. Avaganda. So that's the seeds. So it's just when you pass it in later, is it? Into the features? Right. Um, right, so your pnex is taking a pointer to device features 2. Yeah, what was the validation error message? That's a good point. If unknown type. It doesn't send it, or does it? Have you made sure that that type... Wait, what was the number? Unknown type. Unknown type. Here. Right. So you open up the Vulkan header. Yeah, physical device shader object features extent. That's correct. You can tell. Right. Oh yeah, why isn't the P next? Yeah, maybe that could be it. Yeah, the physical device features 2. No, features 2 probably goes in there. And it says it's got to go into device features 2. Filled in whether or not it's supported or not. It can also be in the P next of device create info to select. Right, so it's got to be in the P next chain of the device info next. So dev features 2. So that's up there. Cool. 0 div. Does 0 div point to anything? Where's your 0 div P next? Is that the error? Right. Is this in here? Shader object. Oh, have you got an old version of Yeah, you might have an old version of your validation layers. What have you got the latest version? Because it's supporting extensions, right? Yeah, take a look at the new version. Because I don't know, maybe your code is fine. Yeah. Just make sure you got the latest and greatest one. But you'll note your P next. Oh, you did the 0 div P next here. But what points to this one? Maybe I'm missing something. Because this gets declared here. How does your NOPL even show up? Oh, there. Sorry, I'm completely missing it. Right, they all point to each other, right? Okay. Yeah, because it is coming across it, right, as an error. Yeah, update the validation layers and let us know how you get on. Because I feel like they do support it. Because there was a GitHub thing we saw, right? So perhaps that's the issue. Yeah, let us know how that goes on. Yeah, you wouldn't want to live in a world without validation layers. Right, we need to add a couple of one of these things as well. So void tab header, one, and you just pass in a core string. So the problem is with the widgets, yeah, when you start a widget, if you're halfway through the tabs, maybe it will assert. Yeah, I think you'll do that. And then there'll be a C string version as well. Okay, so I think that's pretty decent. All the crap's going on here, right? Sweet. Well, that seems pretty good. Can I change any names quick before I decide on this? Tab area. Yeah, I like it. Right, let's record this thing here. Okay, so I've gone and designed an API for how I want this tabbed area to look, because we want to add tabs to this texture viewer so we can switch between different screenshots and compare pixels and things like this. So the API is going to pass in this rectangle, this tab state, a bit like the split state from the previous devlog, and then the style. Then if it's visible, right? If visible, you have to go over all of the tabs and make sure you pass in a string for those, and this will go ahead and render or put the strings in for these tabs, or maybe render the boxes. I don't know. We'll see. And then from here, you do the selected tab, basically, you render that. And then you say selected tab, or you say tab area end. So here's the prototypes up above. So here's all the state. So there's this in-out parameter for the selected tab index. There's the tab count, which is an in-out parameter. The tab's capacity, so the maximum number of tabs we can support. And then if you click on the new tab button, it will set this boolean to true, and you'll be able to say if there is a new tab, you'll be able to or you have to initialize the selected tab index. And then if remove is true, you have to make sure you shift remove the selected tab out. So these obviously need to be handled within here somewhere, but we'll do that when we actually implement the stuff behind the scenes. So let's go and implement this in the UI system now. Cool. Oh, it's way behind, is it? Sweet. Yeah, we'll do that now. That'd be good. Awesome. Well, I'm glad we've hopefully found your problem there. Sweet. So what is next? So I can't actually forget. It'd be very easy to forget this. So let's just write it out now. If tabbed state. Yeah, it'd be better if I did this earlier, but or before I recorded that. But it's okay. Removed. So if is new, we're just going to initialize the tab. So to initialize the tab, I think I just have to. Well, we should really make a function, probably. Tab index, and then probably we'll do a remove as well. So we'll quickly go and add those boys and girls, because there might be shortcuts and stuff, and you know, so well, maybe it's the same. Anyway, it doesn't matter. So if is new, tab init, tab state, select a tab index. Nice. So basically where we do a GPU initialize, in here at the bottom, yeah, we want to initialize the tab there. So we just want to make it white basically. I think we'll mem set everything to 0. So core 0 element, and we'll 0 the element in the array, which is GPU textures, texture viewer, tabs, tab index, boom. So we 0 that single element. Then we set 1 to the white property field, whatever you want to call it. Now to remove, we need to do the lovely mem move stuff, right? So basically, yeah, I forget how to do it exact. So luckily, past me has already done this code. So it's going to source core C. There's a mem move on the remove. Right. Plus amount, less than that. Yes, you only do a shift remove when. Right. So amount is 1. So this is at the end, right? GPU texture viewer tabs count. Well, it only really needs to return true if. So I guess, yeah, the UI system can do this if statement in there, so you don't have to care about it outside. So really, destination would just be address of tabs tab dst1, so the next one after, and then we mem move the number of tabs take yeah, see that's the bit of logic I would have forgot. Or probably in this if statement as well. So we need to make sure this is inside the tabbed thing. Whenever we do a remove, we want to make sure that's in there. So let's do the mem move there. Cool. So I'm glad we got those there in. Deref, and well, I guess that's fine. But this is an extension from back in 1.1. Is it? Did they add it in? Is it an extension from back from 1.1? Because they added it like 2 years ago. Did they add it? No, they didn't add it 2 years ago. Yeah, that's the interesting thing about it. They did a blog article here last year, and I remember seeing. Did it say 2021? Oh no, shader object. This came out in 23. Yeah. Yeah, but it came out 2023, I think. Yeah, that's when it came out. So you do kind of need kind of new, well, in the past year. Well, probably less than a year. I'm not sure how quick they did the support. Right, so that's super nice. Let's go ahead and quickly adjust this then. So this needs to be in a whole big auto statement. Rightio. Things are looking good. So now what we need to do is move this all into a header file and then go full ham on the implementation. Right, so at the bottom here, we're going to add this one. Oh, yeah. So let's go and implement these behind the scenes. Mouse area. Sweet. So basically the idea is we do a widget end here and then a widget start. This tells you whether or not it is visible or not. And then if it is visible, we're going to here and do some extra bells and whistles. Is that right? When you do your headers, the headers will do all the tabbed areas and they do start, end, start, end, start, end. So I think we need to set something like, so maybe we say we can't have multiple tabbed areas. Or should we? So what we want to have is the ability to know. Oh yeah, you can't have a tabbed area within the headers or something like that. But you can have a tab and a tab. Yeah. So this tabbed state needs to be set in some global somewhere. So we need to say like G UI dot tabbed state equals state. So we'll nick that pointer and stick it there. So I think it'd be quite minimal maybe. We need to probably change the rectangle a bit. Maybe you need to have your tabs rectangle. So if you keep cutting, yeah, that's something interesting. So GUI dot. I guess is it part of the, is there a build thing or like? So I don't have a build state, I have a draw state though. Okay, so I think we're gonna have a rectangle in which with a tab headers header rect. So that'd be a cut top. UI cut top from rectangle. Based on some kind of style tab header. Well, you don't even need to do that. You just need to say like, what is the size of the text plus any thickness, vertical size for style, margin padding and all of that jazz. Yeah, something like this, padding. Probably a bit of margin as well. So probably call this the tab outer height. Cool. Awesome. Good stuff, Wojilla. Glad to hear, man. This is the way. Yes, I think that's pretty legit. Cool. So you produce this outer, or this header rectangle, which we can keep cutting. Now, if you have like, your tabs can go off the screen because you haven't set a specific width. So maybe your is tab width a style? Or can they shrink? So when you have the tab, maybe you can specify a size for each tab. That's interesting. Something you could just do. But then you could probably have it automatic, where you say, well, there's only so much room for the tabs, and maybe, you know, I think the web browser, as you add more tabs, when it fills up, it will reduce them all. We could do something like that. It's not too difficult. So you could probably set in here like a, so you want to get like a tab inner. Well, see, you got the rectangle here. So the inner width is equal to rectangle, well, UI rectangle dims rect dot x. Then you actually want an outer width for each tab. So that'll be horizontal this time. Wait. No, not width for each tab. What are you talking about? Yeah, so you want to produce a tab outer width size. So that is tab header. So headers rectangle or header area rectangle. Then you want the header outer width. So that would be inner width divided by the number of tabs that you have. Then you want to round that down to the nearest pixel. Bit of fluff. Cool. So now we just gotta. So I think that's pretty cool. I think this is all we need basically. So let's go and put these in the global thing. Let's just chuck them here like. So header outer width, UI rectangle, then tabbed state. UI tabbed state pointer. I guess you only need it as const, but I don't know. Right, so this is pretty good. So when we start a widget now, we've got to be careful. We've got to say, if there's a tabbed state, then like assert, because we don't want to, you got to put it in widget start, and maybe there could be an explicit flag we can do to say ignore, like I'm a tab header. Yeah. Oh, this is gonna be good. So you'll say, yeah, tab header. So that's passed in when you create a widget. So what we'll do is we'll assert. So you have to initialize all the tabs, and if you don't, it will be an issue. So core assert that flags, so that it's not a widget flag of tabbed header, or GUI tab state equal null. So we want to say basically tabbed UI tabbed tab header has not been called as wait. Yes. Has been called this many times, but needs to be called this many times as stated by UI tabbed state dot tabs count. Something like that. So that's pretty neat, I think. So we need another one. Actually, we missed it. So this would just be like tabs tab header next index. So we initialize that to 0. And then tabbed state tabs count deref. Cool. That's pretty good. So in yes, here we'll say tab next index 0. Awesome. So now the assertion is, right, wait, this shouldn't exist. That function shouldn't exist. Usually the C ones are defines. Core string C string. Cool. Right, I'm glad that's one less thing to deal with. So should be quite straightforward, right? Basically, we want to assert to make sure we actually have a GUI tabbed state, right? So here we're just saying, you know, we're not within a tabbed yes. So then what you want to do is say, you want to, I guess, up this by 1 at the end. Plus equal 1. Then you probably want to say if this is equal to the GUI tab state, deref that, selected, no, sorry, tabs count. Where we've reached the end, then we want to set this to null. And say we're finished. Now, the job is to do the box. So we can't really just use box, because if we used box, then the issue is the flag isn't set. So we could go and add a flag thing in there, but you know what, box is just dead simple. So let's just copy box and just be done with it, right? It doesn't matter. So, so here's a copy version of box. We don't really need an ID. Do we need an ID? Technically we kind of do, but we can just fudge one. We can say U32 max from the back. Take the header index, and that ought to be good enough. Technically, the user could go and forge this ID. But maybe what you would actually do is probably wrap them in another. You could wrap them in another widget ID and lessen it. But then there's a lot of widgets that go on, so you maybe. Oh, I don't know. You see. We could use this top rectangle. Where's the cut? Yeah, we could use this cut one. Oh, the header should be visible. So header so basically you could just set it to U32 max and hopefully no one uses that. But yeah, on the inside. And then you'd use the rectangle there, take the address. And then it shouldn't mutate if you use the no box with the 0 style. And then you need to do 2 widget ends here if it's visible. Because there'll be 1 widget then 2 widget. So I guess that's better, and then you can just do a linear index ID here. The rectangle that goes in would be a cut left of this area rectangle. So what you want to do is get your new rectangle. Rect. You're cutting from the left. Wait, where's that pointer? No, it's not pointer. Why is it not erroring then? Ah, weird. Cut left. Then there's a specific width, right, that we made. GUI dot tab header outer width. Because we basically divided it by the number of tabs. Wait, what is that? Tab index. What? Tab count. Okay. Whoops. Then rectangle goes in style. Needs to be that box style, but we didn't get it show up. So style. Yeah, we should probably store in here the tab style as well. Well, actually, why don't you just pass it in here? And also, why doesn't the user just pass in the ID into here like a regular widget? It is a widget at the end of the day. So why? And then that just solves all the problems we've just been trying to solve here. So, yeah, okay, so UI ID, passing the ID for the widget. What does it? Because then the user has to explicitly pass that in, and that just feels a bit like cumbersome to do as a user. Because it could, no, but it would just be the line number. But you'd having a for loop. Yeah, no, we'll do that automatically. But the style thing being passed in is a good idea. So the style being passed in, that's a good idea. So then you would do a, oh, no, because then the width is calculated based on some styling thingy here. So you need to make sure you have no margin. But then you might want margin. Yeah, because you've specifically, the margin will move. Oh, no. No, I think it's okay. Yeah, no, it'll work out perfect. Don't worry. So rectangle has to be an address instead. So we'll draw the box. We actually need to put a bit of text in there. So I think it's called button text. There's one. Align to the middle, I guess. You draw the background first, clip it, get the drawing rectangle, and draw the piece of text. Cool. So I think this is literally it. Yeah, so we should be able to try that out. It's going to be legit. Just got to change the header for that. And then right, we've not got the new button to open up a new tab. Neither have we got the, we've got a new button for the new tab, or have we got the ability to close tabs yet. There's something to work on still, but at least the beginnings is here. And maybe you want like a max. Like the first one is going to be so long, but yeah, I guess we can get the new tab thing in as well. For that. One minute. Oh yeah. Right, so we should be able to now go to here. I guess we'll call it box style. Awesome. Oh yeah, so we need to make sure there's that. Okay. When we do the remove, we've got to make sure there's that if statement, say don't remove the, yep. So we need to make sure every time we leave here, that tabbed state is new These are going to have to be, we'll set them to false now. I think these are going to have to be stored globally, and there'll be 1 frame late. Yeah. All right, so let's take a look at this thing and see how. What? G. Initialize tab 0. Okay, so hopefully this doesn't blow up the computer. Let's go. All right, just a CPU crash. We're okay. Can I access with a null ID? Right, so we didn't handle the case when the resource is not selected. So we go over here. What we actually want to do is say if we got an actual ID, we fill the buffer in that way. If not, we fill it in with empty, or I guess some special looking name. Excellent, so let's try that one out. Right, so apparently we've not got anything else showing, which is kind of sad. But there's the tab. The whole texture viewer is now gone. Evaporated. Rect is there. So rectangle got cut again. And then the remains got put in. Wait. Yeah, we cut top by the height, that's fine. So why is my rectangle not working? Rect. Window rectangle goes in. Display area. It's definitely visible because it's going through here. Now if I were to not do anything here, this is, so we default to 1 tab, so that will not run. Right. It's clearly not running. What is it trying to run? Right, something's painfully wrong. So it was running through there. It would end up running through here. Go into box start, then go into widget start, and that should have done the assertion. Oh, we didn't say we're a tab, did we? Whoops. We didn't say we're a tab header here. So maybe the assertion was, the Boolean logic is wrong on the assertion. Yeah. Okay, so the Boolean logic is wrong on the assertion. Assert. Yeah, make sure that it is a tab header, or the state is. Tab state is null. Okay, so that's the reason why we wasn't getting the assert earlier. Oh. Huh? Shoot. We didn't set the tabbed area state right away, did we? We said it if it's visible. Oh, there's a second time where it does it. Whoops. Right, let's watch out for that. There we go. Okay. So right, so we've still got the same problem. But anyway, the tab's there now. Let's check if that assertion works. So we can take one on here and not call it, and it should now assert, say, hey, you've not called tab header. Right, there's the assert, which is good. So saying here, your tab header has been called 0 times, needs to be called 1 as stated by this. Cool. I like it. So this gets called, it won't be using rect, right? So why then, like what's up with the rectangle now? Core breakpoint. Let's open GF and take a look. Zero, zero, and then, you know, it's got some size. Nothing wrong with that. So is this one then not become visible? Ooh. Wait. Why did it crash? It asserts there. Oh, did we not compile it with the extra? No. Oh, I didn't remove the take one. Whoops. Okay. So this should be in the box drawing stuff, right? Box. It's not visible. What? There's a big old rectangle there. Completely visible. Oh, the clipping. Oh, shoot. I know the problem. Right, so this end, that end has to happen after you've finished doing all the widgets. So that widget end needed to go here when you finished doing all of the header widgets, right? Which closes this one. So that's why the clipping rectangle was wrong. Hey Sully, seen any good movies lately? Not really. The last one I went to see was June. I might be in cinema on the 31st. But yeah, I don't know. Yeah. Last one I saw was June. Have you seen any, Sully? Oh, you're not talking about cinema movies, right? Oh, what did I watch last? I watched Jurassic World. Yesterday it was alright. What else did I watch? I watched Rebel Moon. That wasn't bad. Seen Rebel Moon? Oh, director's cut of what? My days, this blinding white screen. Ugh. Rebel Moon. You watched this one? They got two films out there on Netflix. Apparently they rated 5.6. I thought they weren't too bad. To be honest, you can never trust these anyway. People too into their films just do it, and if you're a bit of a casual watcher, then it doesn't really apply to you. But yeah, this one went bad. Okay, we hit the break point. Whoops. Sweet. So we got the tab up here. Bum 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 bum. So the next thing is to make it, you know, have a plus button. And maybe we can have like a min width or something like that. Or a max width, maybe, on the tab size. So it doesn't go completely bonkers like that. Yeah, where would that max tab? That's more of like a style thingy, isn't it? It's like a style thingy. A max width on the style. So we'll chuck that in, and maybe we'll say, you know what, I like 64. And then in the UI, when you calculate the tabbed outer width, you go, well, give me the minimum one between style that and the one you calculated automatically. Right. Did I do a silly? Well, that was the no box style. Whoops. Right, so the box styles got updated now. Sweet, so 64 is obviously super small. So what I probably want is something like maybe 400. I got a video. Oh, there we go, empty, and it's center aligned the text. Send it. They left align it there. Yeah, maybe we should left align it. So luckily we copied and pasted that code in manually. So it's just a case of using this. Well, probably just using the standard draw rectangle actually, and not bother with aligning because it's already left aligned. No, it needs to be left aligned to the middle. Left whittle, what? I didn't say that. Right. It's not aligned by the padding. Right, it's adjusted. We've got to shrink it by the padding. But it should have done that. That's the whole point of the draw rectangle, right? You shrink it by the padding. Oh, no. Shouldn't be the draw rectangle here. It should be the actual rectangle. That one gets shrunk by the padding when you pass it into here. Sweet. I'll see you in just one sec, Sully. Okay, that's left align there now. Now we can put a close button here in the future, and then we can add the new button as well. Cool. Yeah. Right, let's watch Sully's little thing he wants me to see. What have you done, Sully? Trailer Park Boys, eh? Very nice, very nice. Right, so actually making good progress on that tabbed view. Should work on that sort of new tab button and then the remove button. And then I think we're basically there. Pretty good. So I'm just gonna take a quick break. Why is that so blinking small now? I shrunk it, didn't I? Oh no. That's alright though, isn't it? I did a find and replace and I shrunk it hard, but that's fine. Well, there's like a radius thing. Slider grip. Oh shoot. Yeah, slider grip radius. It was 16 before, I think. Yeah, there you go. Massive. Big difference. These are a bit big to be fair anyway. Maybe we should make them 12. There you go, it's a bit better. Cool, so yeah, let's add this. Okay, right. Let's take a quick break and then we'll add those buttons. Right, BRB. Alright, welcome back everybody. Some more H2O. So we want to add those new buttons. So we can say so I think we need to make enough room off the end. So there's a particular thing here. So we always want a new button to be visible unless you go off the end. So or maybe it can be disabled. Yeah, the new button can just be disabled, but we'll always make room for it. So there's a tab header width. Now That width also probably has to be right. So you want to take away the size of a button. Hmm. A text-driven game? No, no way. I'm just using a terrible font. It's 3D. Zoom. I just got a texture viewer, and I'm just testing out the UI library. The UI, immediate emoji UI thing that I've written. But yeah, the theming is not really been thought about. It's just quickly configured variables. The way the way the UI gets themed in the UI has been thought through, but not the theme that I've constructed. That will be done in the future when I care about it. Right now I care about doing some 3D stuff first and making this all good. But to do that I need a quick texture viewer which allows us to view, view textures and interpret the pixels as, and view them at particular points in time, and also be able to take a couple of screenshots and compare them. So we're just finishing up on this tool, and it's going to help us develop the rendering technology, and then I can come back to doing this properly. But yeah, it's going to be legit. Thank you, thank you, thank you. It's going to be legit. We're just wrapping up on this tabbed view thing, really, basically. And then after we're doing screenshots, and then after screenshots we're doing PBR. So physically based rendering to make those spheres look decent. So if you have a new tab button that goes after, you basically need to work out the width of one of those. You need to work out a new tab outer width, and that is probably just going to be a plus button. So enough for line height, horizontal padding. Okay, just one character and voila. So you want to make sure, right? This is probably your average. Yes, you probably call this the average or even. You have like a min-max thing. Yeah, I guess we'll just take away the new tab thing. You need to make sure, is this taken away as well? No. Yeah. Take away this before you min it. New tab outer width. Okay. So now that that is sensible, when you do these tabs, you need to make sure that when you're doing your last tab, you need to do another button. And this one needs to be specifically needs to be a button, right? UI button with a bit of text. Takes in a rectangle. That rectangle is this. Here we do another cut left. Then we pass in the rectangle pointer, followed by the string, which is going to be a plus, followed by the style, which is going to be style. So if the button is pressed, then we can say GUI. See, the problem is the tabbed. Oh yeah, oh shoot. Hey, Majestic Mac, how's it going? How you been? Yeah, I think I want to take a pointer to this. UI tabbed, call it state. Then we'll clear it so it doesn't trigger it again. Then so I guess we could always, yeah. Got some ideas. Then here, if this is the case, we store in state and we say tabbed new tab equal true. I was just thinking that we should probably do this regardless here, and we can get rid of that tab header thing. Then we can restore it. If it's not the final one, we can restore it. Yeah, so not finished yet, so restore it. And then this flag thing can go. And then really we can just do a box with a bit of text in it. That's far cleaner. I like it. So really this could just be a box. Then the box does a bit of drawing. And then is visible into a box, and then I guess you could put a button in there as well for the remove, but that comes in a bit. So this will set is true. The next time, wait a minute, and then so you want to make sure that you set these to when do you set these to false? You set them to false here when the UI tabbed area start ends. They will never get passed in a frame later. So you need to make sure so this one is fine. You would simply just, set this to be the result of that. But with the remove, it'll be a bit different because the remove is actually part of this here. So maybe you'll store it globally. GUI tab remove, and you'll remove the selected tab. Yeah, okay, we'll do remove in a bit. I know how to do it. This is fine. So this should do the is new. Oh shoot, what do we do? We didn't end it. Wait, what? 2232. Shoot. Okay. A massive tab button. Click it. Not doing anything. Oh, we should have upped the tab count by 1. Right? I think so. You should have upped the tab count by 1 and then move the so this can only happen providing that. Well, wait a minute. Damn it. If that and state tabs count plus 1 is less than state tabs deref less than the capacity, then state is new true. Then we need to advance. We need to make the selected tab index to be equal to state tabs count. Then yeah. Then the tabs count is in plus equal 1. Right, we increment it by 1. I think that's the logic was missing. Does it ever get cleared? This should get cleared. If not, just create infinite tabs and, you know, get filled up pretty quick. Right, that failed. Where did that fail? 2218. Here. Oh. Between tabs start and end. What? I guess it's not visible now. Right, here it is, tab start. If new, initialize the tab. If removes, remove the selected tab. Go over all the tabs, initialize. Oh shoot. It would have done another tab. Wait a minute. Because we would have looped over the number of tabs here that would have got incremented, right? No? Wait a minute. Right, you'll be going through here, and this would increment this one by 1. Ah, that's bad. Maybe this could be a while loop. You could say while tab header, but then you've got to don't get an index. It's not a good idea. Yeah, we're incrementing this value here. Well, we could say you always have to store a local. First, before you use it. Or see, this won't be initialized yet, and it would go around again. So maybe you should mark is new, but then if is new, we do it in the next, yeah. If state says that it's new, we are going to then do the logic here. So at the beginning, when you begin the tab thing, at the tabbed area, we'll say select a tab index, and then we up it there. Yeah, that makes more sense. Okay. So let's give that one a go. Oh, what's happening there? Yeah, and we can increment it by 1. Cool, let's give that a go. Boom. There we can add tabs. So the add tab button is a bit too big, but as you see, if we add them, they do get smaller, which is what we wanted. And we can only go up to about 12 for some reason, but I don't know what's going on there. So let's, that new tab size is way too big. The rectangle should have been cutting is just the size of the outer tab width. So let's investigate why. Oh, there's only 8. There's only meant to be 8 tabs. Yeah, that's fine. So that's correct. Now it's nice and small. Ding, click, 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 click. So it's off by 1 for a frame. It adds it. Apparently gets rendered. So we see it blink for a frame. That's not very nice. Wait. Did it blink for a frame? Why does it blink for a frame? Oh, because the tabs... Ah, right. It should up it earlier. Should up it there. Because it uses the tabs count here and calculates the width. So it will be the wrong width for the first frame. Now it's not. Sweet. Cool. So we can keep adding more tabs until we get to maximum. Here is where we shouldn't be allowed to do anything. So we should disable that. Luckily it's very easy. We simply UI disabled. Scope such that, wait a minute, and this is that, we don't need that. So it's disabled when that is greater than or equal to. Then we go in here, and we get to try it out now. So we should see the button gets disabled. So we add. And there we go, it's disabled. Nice. So that's cool. We can't click on these yet. That's an obvious issue. So this should really be a button. The problem is it won't be left aligned anymore. If we use the text button, so I think we'll have to do it manually. So do button, we'll manually do the bit text in there because we can left align it. If you click on that, oh yeah, we'll also have a remove button inside the actual button. But yeah, so if you click on that, so what does this do? Returns visible. Right, so you get the, yeah, you get the focus state. And you want to know if it's been pressed. If it's been pressed, we can then say, hey, by the way, that selected tab index state is equal to whatever the current tab index is here. How do we know what it is? This next index. There. That should be as easy as that. So we hover over these, you can click on it, right, click there. You can view the depth texture, click there, view the surface. Right, switch between those there. Right, so actually seeing it come into action now. It's pretty nice. You can't see your selected tab. They should probably be toggle buttons then. So, wait, how does the toggle button work? Oh yeah. There's an is active thing, switch flag you can pass in. Oh right, but there's a toggle button that does it for us. Even though you need to use the raw widget. What's the extra one? Right. So we'll just do boolean is checked. That will be based on whether or not this is true. So if it's checked, then that thing will be active, be in the active style. Testing the active style now. You can click here. These stay in the active style, right? There you go. Sweet. Much better. Oh yeah. Wait, what's up with the zoom? The zoom is not per tab. That's not good. Quickly fix that. Who didn't put the view scale in there? What a melon. Wait. Oh no, sorry. Wait. No, you want it to be, yeah, it was there for a reason. It's got to be outside the tabs, because if you have the same texture that you're viewing different versions of, you want to be able to alt tab between them, and yeah, without having to synchronize them manually. That's correct. All right, that's cool. So what is, we have to do the remove next. Remove. So we're nearly there. There's also like keyboard controls. They're another thing. But yeah, so we need a button inside of a button. Luckily, we've got support for that. So inside of a button, we want to probably cut from the right. So the thing is, where we do the piece of text, that actually needs to be a cut left. So we'll have this sort of like indirect. We'll cut left, we'll cut right by about the width of like a, so we'll calculate this width thing. This will be like a new remove outer height, okay? So basically we're going to cut right by this thing. And this will be the rectangle for the remove button. So that'll be equal to rectangle. Take a copy. Inner rectangle is gonna, we'll cut the right hand side, get the right hand side cut here. The left hand side is reduced. Then we use the inner rectangle to draw the text. Then we use the remove. If we are the selected tab, we display a remove button. If this is true, then we display a button and we say if UI button with a bit of text, we are going to pass in the remove rectangle, and we're going to pass in the you see, this only needs to actually happen Yeah, some of that. So we need to do the cut, providing that that is set. I guess you could do it. You know, it does need to be split into two things. So remove rectangle. We want a piece of text to just be a negate symbol followed by the style of the. So I guess the only problem is the tab style has to have the same. The buttons have to have the same style as the tab itself, but hopefully that's okay. So if you press the button, then we now need to make it such that the widget gets removed next time. So we can't simply set the state now. Can we? We need to find a place where we can set it to false. We need to find a place where we can set the widget. The remove is removed to false. Where are we going to do that? Because we can set it to true here, but where are we going to set it to false? So I guess you can maybe say, hey, next time you go around, so you just say, well, you don't know, you could have you could have multiple tabbed things. So maybe there's two of them. So you say is removed. Nice. But then like this is inside the header. Yes, you can only remove the one that you've got open right now. And then I guess we could say if you're the first one, if I am the first one, GUI dot tab next. If I'm the first one, clear this to false, then one of mine is going to set this to true. I guess that's the way. And I guess we could clear them both. I don't know. I think that's okay. So then, yeah. That minus button is small. Something's wrong there. Cut right. Right, the problem is you got a widget inside of a widget and it's got like borders and padding and things like that. I guess it's worked out okay, right? It is a minus button. It should be a box with a bit of text in it though. But it's actually just worked out. So let's just leave it at that, right? But the problem is that it's not. That should be clipped. Oh, where's the clip? We should be able to say UI clip. Crap. It's a bit complicated. But you want to adjust the clipping a bit. Already that button should just be rendered on top. Maybe there shouldn't have been a... No, it doesn't matter. I guess the clipping's not that bad. It's okay. Yes, the remove. Why isn't it being removed? So it should have... I guess you're going to say if remove. So you're only allowed to remove providing that. So I guess you want to take away one. If remove is clicked. And then the selected tab index is... is equal to the one at the one where you was just at. No. You don't want to move it, that's the problem. I guess the see, how's the caller of the API going to know if you got to delete the one at the end? Because you'll be dangling off the end. I guess when we call the selected tab index has to be minned in bounds here. So you'd have to say the deref of that is equal to the minimum and the number of tabs you currently have. So I guess that would work with the logic. So this was called after the thing has started. So the thing starts, if the tab gets removed, we just take away one on the tab, select the tab index. Sorry, just take away one from the tabs count. We don't do anything with the selected tab index. The user of the API is going to remove the tab with the selected tab index. And then when you call the first time you call one of these, it will clamp it with inside the bounds. It will clamp the selected tab index inside the count. And I think that fixes the issue. Right, let's just try and remove it. Ooh. It's inside our code. That does the tab removal. Yeah, so it only call if it's at the end. You don't want to call... You don't want to make it remove the tab if it's at the end. If that's not equal to the selected tab index, then remove it. So in viewer selected tab, now crashing. Oh, we didn't do min take one, did we? Whoops. When we clamp it. Ah, there we go, sweet. So let's double check. This one's depth texture. Do the remove. Sweet, depth texture stays here. So if I am to remove this one, it removed the wrong one. Why did it remove the wrong one? So I was on tab 0. I clicked remove. So it made remove equal true. Then remove comes into here. We keep it because selected tab index is not equal to tabs count. Wait, that's always going to be true, isn't it? Oh no, because it's taken away one. Okay, so it's going to do the removal. Wait. No, it would have reduced one. Right, it should have done the copy. Select a tab index. Move over to the destination. Tabs count, no, that's changed. That's already been reduced by 1. So it didn't move anything. I think that was the issue. Right, depth texture, so open that up, go depth texture, close. Sweet, that worked. Cool. That's nice. Yeah, you shouldn't be able to clear out 0. It's the other issue. So yeah, I think that's most of the things actually. We should really document this. Where's the remove thing again here? So you can only remove also providing that you only really want to show this at all if state tabs count has anything. Right, if you have, wait, if you have more than one tab. Sweet, so I think that's mostly, it's mostly finished. It just needs the hotkeys, but I don't know if I want to make this part of the system. Yeah, I don't know if I want to make it part of the tabbed widget thing, or if I want to make it part of the actual, yeah, make it part of the thing that's calling into the tabbed widget. So I just want to double check the code and make sure it makes sense, and then we're going to go and do a recap. So is new, and the selected tab index equals tabs count. Oh. Okay, so I think let's go and give a demo. And let's do that. Okay. Okay, so we've gone and got the tab view thing implemented now, and it's all here. So we can open up new tabs, we can select We can switch between the tabs. See if I click depth texture here, we can click and open up these, switch between these two tabs with the mouse. We can always open up more tabs, and then we can close tabs, and yeah, I can close the tabs before and after. So we are missing some things like tabbing between things with the keyboard, like keyboard controls basically, and also reordering is kind of, I don't have reordering yet. So but it's most things there. This is not this is now usable. Damn it, let's do that one again. Close though. Right, so we've now got the tabs implemented. So if we take a look here, we can open up a new tab. We can select the depth texture here. We can go and select the font texture here. We can switch between the depth texture and the font texture. We can close the font texture. We can open up a new one and then close that one if we want to. So this is basically all the functionality that we need, but we are missing the keyboard controls and to sort of like reorder, because the keyboard controls are going to be really nice when it comes to comparing two images. But yeah, super happy with this result. So let's take a look into the code and see how it works underneath. Sweet. Don't think I missed anything there. So I think we'll do a quick recap on the how it gets called, and then we'll dive into the other bits. Okay, so quick recap on how the API actually gets called, because we haven't got any of the extra stuff, the prototype stuff that was here earlier. So you have this tabbed state thing. It's persistent. It's got to be persistent between frames. Declared as static. We initialize the bits that we need. So like the selected tab index, or the pointer to that, the pointer to the tabs count, and the capacity of the number of tabs, so we can't add too many. And then we say if the tab area is visible, then we're going to go into the tabs area. And we've got these little out parameters which say, hey, if we've added a new tab now, can you handle that? So you are in charge of initializing the tab. And then if you remove a tab, you're also in charge of shifting the tab array down by 1 as well. Maybe we can move that inside. We'll see how this goes. And then we go over all of the tabs, and then we basically call this tab header with the string that we want to go inside the tabbed header. And we have to call this for every tab that we have. If not, there will be an assert. So let's dive into the internals and see how this works. So when we begin a new tab area, we start it up and it's just a, hang on a minute, why is this a focusable widget? That's got to change. Then basically we've got this state. Inside the state, if it's been marked as it is new, this happens later on, which you'll see. We make sure that the new selected tab is the one we've just opened, and we up the tabs count by 1. Then if we're removing a tab, we deduct the tabs count by 1, and we let the user know that they need to remove a tab when the currently selected tab is not the one at the end. Right? If there's the one at the end, it's just you just take it away and it's gone. If not, they need to do a shift remove and move the memory over the item that's been removed. And then if the tabbed area is visible, we calculate the tab outer height, so the outer height of the tab, and then the new tab outer width. And we're basically what we're calculating here is what is the width of the of a single header. So we do the width of the whole tabbed area divided by the number of tabs that we have. So when we add so many tabs, they shrink, a bit like how it happens in the browser. And then we take away the new tab outer width, so we can always fit the new tab button at the end. And then we min that with the tab header max width, so we don't have a tab that goes all the way to the end of the screen when there's only one tab there. And then we have the tab area rectangle here. So when we add those tab headers, we can just keep cutting to the left and putting all the tabs in there when we initialize the tab headers later on. Here we've just added another widget where all the tab headers are housed, but it's invisible, but it's just there. And then we set this global variable where the tab state goes. So the state that gets passed in with all the parameters, or pointers to the parameters, that just gets stored globally. So this means that when we start a widget now, when we start any widget, if this tabbed state is set, then it means that the user has not called UI tab header enough times. So this is a great check to happen. So it means we never have partially initialized header data. So the final thing to look at is the tabbed header. Well, the tabbed area end is just a widget end. It's just very basic. And this only gets called when the tabs area is visible. So just like every other control. So the tabs header is where things get a little bit more complicated. So we take the tabs header state out from the global variable and we clear it out. So we're allowed to put our own little widgets in here, and we'll put it back in there at the end if we need to. So if we're the first tabbed header, we're going to clear out that is removed state, because this is the best time when we've got the chance to clear it out. So that means the user, when they call the start, they can handle that the is removed and remove it. But then when the first time this is called, it will set this to false. So the next time it comes around, it won't call it again. Now, the selected tab index also gets minned just in case it goes out of bounds. Then we calculate the new and remove button tab outer width. So when we add these new or remove tab buttons, they have a width there pre-calculated. So this is the toggle. This is the actual tab header. It's a toggle button. So when it's active, it will look like it's pressed in with the theming. So we just basically set the check to there and then pass it in. Then if it's visible, and we are the currently selected tab, we're going to cut to the right and produce ourselves a remove button, so long as there is more than one tab available. And then if we press the remove button, it is now removed. Then we draw the text for the tab in the header. And if the tab is pressed, it is now the selected tab. Then we end the button, and that is the header. And then this is the bit of the logic at the end where we say, okay, we're going to advance to the next tab index for the next time this function gets called, the tab header. Then if the tab header index is equal to the tabs count, it means we've gone over all the tabs, and now we can end this loop here. So if it's not the end, we set the tab state back. So that means the assertion will fail. Oh, sorry, the assertion will be tested, and it will fail if there is a different widget which has been called other than this one. But yeah, going back to if we're the last widget, we end up displaying another widget afterwards, which is the new tab button. But this is disabled if we've added all of the tabs that we can possibly add. Then we cut to the left and just do another one, which is the button, and the return goes into the is new state there for the next frame when tabbed area start is called. So that is basically the tabbed widget. Cool. That was really good. That went pretty smooth. Happy about that. So that's a lot of stuff done today, guys. That is all of this. It's going to be quite a long video as well. It's probably like a 20 minute one because of all that stuff. But it's cool. Right, let's record an outro for the YouTube channel. So for you guys that don't know, there's a YouTube channel where we post the devlogs of every stream. So the streams get cut down and they're up on there. You can go and watch them, like them, subscribe, all that jazz. We're going to go ahead and record the outro now. Let's just get all the things in order. All the ducks in a row. 9. 16. Cool. Right, thank you so much for watching, guys. So this one is day 116, and we just take a quick recap over this lovely to-do list that we've done. We've fixed the zoom speed, we've sorted that BGRA problem, upside down images have been sorted out, array layers, 3D images, we can view integers now, we sorted out the sRGB and linear problem. Well, sRGB was working fine, but the linear textures wouldn't have been working all right. We now got this configurable black, white, or min-max range value when we view textures, and we also can view individual or multiple RGBA channels. We can turn on and off the channels individually, and we've got a new lovely tabbed UI, which is most of the way there. Just a few more little bells and whistles to be added onto that one. So yeah, if you're gonna catch the VOD, the full VOD, you can do that. So it's day 116, that's on the VOD channel. There's also the Twitch link if you're gonna go and see the timetable for when the stream is actually live. If you subscribe to the VOD channel, we can hopefully maybe stream on YouTube at the same time if people fancy that one. And there's a Discord link if you come and chat in the meantime, ask questions, or just talk about programming or whatever. Also, thank you for everyone who's supporting me via Ko-Fi, which is the preferred method. Those guys get source code access. Also can support via Twitch as well. That also works too, and you can do the same. Right, thank you guys. Have a good one. Catch you later. Man, that was smooth. I'm even super tired as well. That worked out. Cool. Right, so next stream, guys, is on when's the next stream? The day is Sunday, so the next stream is on Tuesday at 6:30 p.m. GMT +1, where we're going to be working on screenshots. So we're going to save these boys out to a folder, and we're going to be what else are we doing? We're going to obviously make them viewable in the texture viewer, which is like the whole reason why we built this thing, is so we can easily do screenshots and compare things, look at, view, just make it very nice and easy workflow for actually just comparing images and all that jazz. So yeah, that's going to be good. We'll also improve the tabbed UI thing as well. Yeah, so then that should be this texture viewer thing complete. So yeah, let me remove the to-do list. Goodbye to you. So yeah, there's a Discord. You're gonna come and hang out and chat in the meantime. And yes. Okay, have a good start to your work week, guys. I'll see you all on Tuesday, if not Thursday, if not Sunday, if not the next Tuesday or the next Thursday or the next Sunday, and so on. Right. Thank you for coming, guys. Appreciate it. Much love.